40 is what it's at. So it's perfect to go right in the ZVS system now. As long as the gravity flyer is hooked up, it now will resonate properly in there. And you saw the power I get here. Dude, I'm dying to put this thing on my gravity flyer. I just didn't have time today. Okay. It's, you know what I mean? Once you get it running, you're like, yeah, let's get in there. I don't care what this. It could blow the whole thing up, man. I may have to start over, and I just don't care. You know what I mean? I just want to see the power get into it for the first time. And I got a spare gravity flyer sitting over here, man. I can run that one in case something happens. But I'm just excited. So.
Oh, it's very exciting because isn't that the missing piece of the puzzle for your gravity flyer to get it to actually work? Is to get that to resonate at the proper frequency and to get the Tesla coil powerful enough, I guess.
Let's just put it this way: when magical things start to happen, my transistor would explode, and not by a little bit, dude. I had like 1-inch sparks coming out of this transistor. So I tell you some of the power I got pushing through this, but as soon as something good started to happen, man, it just boom, blew, just like that. It couldn't handle the feedback to it. It didn't matter how many diodes I put into it. It annihilated it. So I needed something like this that you could push back on it a bit. And trust me, I pushed hard on this thing. I ran this circuit with a very bad resonating coil that was like, I think it was 800 kilohertz is what it was. And I tried to run it with a ZVS circuit that would only resonate at about, 300 kilohertz. And it just absolutely hated it. And it buzzed the number one coil, just, awful. It was total feedback in it. And yeah, so I know this thing's pretty tough. So when I hit it next time, it's going to go hard. Benny, you back?
Yes, I am back. I don't know what's going on. My internet's keeps on taking a crap every once in a while. So I'm just going to be delicate with it today.
Okay. Yeah, the DC circuit, by the way, is easy to do on this. Naturally, it was set up at DC. So all you have to do is take your DC power source, whatever you have, and it'll do sparks at about 40 volts. So 60 volts is where I was running it right now. So what you want to do is hook in your DC power source. It works just like normal. You plug in the positive, negative, and then on the negative, what you want to do is put a switch in the middle of it so that you could turn it off and on the negative right there on that side. Positive just runs clean to your power supply, and it'll run DC just fine. You'll get more resonance out of it than you do sparks at that point. So you'll just get a higher field if you run it in DC, but not a problem at 60 volts. This thing's a beast, man. It'll go for a while. So I was messing with mine for about 2 hours on and off, and I didn't blow up the circuit. It was only until I crossed wires that I started blowing stuff up. So
you don't cross the streams.
it wasn't working properly, so I tried to reverse, and it just boom right then and there. So anyway, guys,
you sorted out the positive and the negative probably somewhere.
This Sean right here, guys. This is the man right here. Anytime you need help with your Tesla coil, look up Sean. He's got this thing down pat. I wouldn't have been able to do it without him. So
it's good to have someone that's done it before on your side there,
Well, he's got a lot of patience too. Let me tell you that right now. You kind of need a lot of patience when sometimes dealing with me because my mind works so fast. It's like I got to slow down. You know what I mean? Like I'm thinking 3 or 4 steps ahead of you, and then I got to get back on your page to see it the way you're seeing it. You know what I mean?
For sure. So. Yeah. Communication it can be tricky, but I think we got a system that works, hopefully.
So, all right, we'll put up another one right here. So it says, running it on DC will provide a continuous wave breakout. Running it on AC with diodes provides a large lightning output. Yeah, just like I said, it gives you the radiant, of energy. If you have it on DC and you want the sparks, you go to AC. So
Hmm.
right there.
Yeah, a lot of great questions.
You mean
here.
if you want the amps, you give it AC.
Yeah. And Sean could probably tell you, Sean, if you could, you know what the amps are going in on this circuit? Maybe you could just let us know. So he's got.
Well, what's the coil resistance? The Tesla coil. What's the resistance on it and the voltage you're giving it?
Oh, dude, I was giving it 60 volts right there when you
And
saw it going.
What's the ohms on the coil?
Oh, I don't know. I didn't check.
What do
It
you
never
think it
came up.
What's the gauge on it?
It's 32 gauge.
About how many feet you say?
Oh God, it has 900 and something turns on a 4-inch pipe, so it's got to be over 1,000 feet.
1,000 feet. That's like a couple hundred ohms, 500 ohms around there. I'm thinking.
There you go. 7 amps from AC Variac.
That's 60 volts.
And 5 amps from a DC input. Sean built a cool bench power supply that he has. It gives him 24 amps on this thing, man. So he's going to be able to run whatever he wants, man. It's kind of jealous. I'm going to have to buy the same thing he did and put it together. But yeah, pretty cool,
That's
dude.
pretty.
So yeah, I'm pretty happy, man. It finally all worked.
Well, it's great when we see like breakthroughs in projects like this. You know, like we all have our hiccups and our hitches where we just can't figure out how to proceed, and then it's so refreshing when you finally see somebody like you is like, yes, I finally figured out what I need to do, and this is my game plan from now on, and we actually have a route to our goal.
Yeah, trust me, it wouldn't happen without him. So this thing was tricky. But all the videos you can watch. So what we're gonna do is in the future here, Sean and I are gonna get together and we're just gonna make an instructional video. You got to do this, put it in Java this way so that it can tell you exactly how long the thing has to be, what to cut the pipe at, what to cut the wire at, what's the numbers you should be reaching when you do wind it so that you can make sure you're in tune with it. And at that point, I'll give you the ohms right there in that list and just everything, how to test it. That way, it's a simple thing. Look, we'll put about, 6 coils in there on what we could build. I got 2 built. We'll get 6 going. Once we have those, anybody be able to buy it off the shelf, have this thing running as long as they build the coil within like a week, man. You know what I mean? And that's what time with winding it by hand. You got a motor to wind it or you buy a coil already, by all means, you'll have it done in a couple days.
Yeah, that makes a difference with having something to help you spin it.
Yeah.
Might be a good business to make Tesla coils.
Yeah.
Hey, man, I'm retired, brother.
No, I mean, you get like a motor set up, make it automated, and you know.
We can still print rodent coil frames, man. Custom made ones. That's a viable business right there.
They're so hard to make,
Not really. Those things are somebody already did all the work on the STLs. We can size them to anything you want.
Pretty much.
You know what I mean? So
we just can't we just can't infringe on anybody else's who has like a patent or anything. But like I know Jordan from Alchemical Science has a nested frame that he does not want monetized. But other than that, like there's tons of frame designs that we can even tweak our own. Like I was thinking about working with a graphic designer and trying to recreate the advanced 3.0 vortex coil. It has very thin openings for the coils, the coil wires to set in. So it's a little bit different than the frames we see, where it's a thick V or a thick opening for a bundle of wire to set in. It's just a little thin V shape opening for the slots. So
you're asking for it.
Down. Yeah, but it's going to be tricky, but I think it's possible to recreate that.
Yeah, you're asking for it, man. Those things, I don't know. As long as the outside doesn't hook in, I guess you're okay. But as soon as they start doing that, you start chipping wires. It starts really.
Yeah, and the smaller ones are very hard to do. Like the advanced 3.0 is supposed to be a lot smaller and compact. So winding is going to be a B. It's going to be a pain in the B.
Yeah, I don't know, man. That's all you, brother. My hands can't tolerate that.
It's okay. It's something I have planned for the future, but I definitely want to get it done because we don't see any of those coil frames anymore, and I'd like to get them available again.
Yeah, that'd be cool. Take some time to design it.
Yeah.
Yeah, I've been backed up on everything, man. I have had 100% focus on these Tesla coils. That's for sure. No.
Yeah, because and what's your like? Are you planning to integrate that anytime soon to the gravity fire system? Like, are you planning on doing any testing this weekend, maybe?
Yeah, this week, all week.
Oh, wait, okay,
Yeah, look, this
nice.
thing's up and running. I'm gonna order 4 or 5 more ZVS circuits because I'm gonna trash some. Let's just be honest. I'm gonna hit this thing with everything it'll take just to see what it does. Then we'll tone it back to where I need it. So,
And how long have you been working on the gravity flyer?
dude, I've had this thing for like several years, and in the last 5 months is the time I focused on it. Like,
Yeah, okay, so about 5 months you've been working on, and we're like, ladies and gentlemen who have just been introduced to this gravity flyer topic. We are or Nathan is on the precipice of solving this thing. Like, he has never been closer to actually getting this to lift off the ground, and this is the missing piece of his puzzle. And I'm so excited to see what it's actually going to do. When you actually get this Tesla coil working with the gravity flyer.
it's going to do something awesome. Trust me, it's right there. You know
So
what I mean?
the Tesla coil is like putting like a radio signal connecting to the flyer, right?
Well, think of it this way: if it's adding capacitance to it, right, and your Tesla coil is a capacitor to ground, okay, I'm now completing the circuit to ground when this thing is on the ground. So the energy's flowing, and it's flowing hard. So I'm pulling it from the earth itself into this thing, and it's coming in as charge, and it's not coming in as voltage per se. So there's voltage coming in the top, but the charge is coming up and it's filling up the bubble that it's in. So it's conversion. So you guys saw my video on when I wound the coil, right? Mm-hmm. And how I got the resonance frequency in the winding coil or the spool wire. It's exactly the same thing. That's exactly what I'm doing. I'm converting that charge that I put in that PVC pipe into the gravity flyer. And it's just hits it once, and it creates a burst of energy.
It's like you said in one of your videos. It's more about the process and less about the parts that you're using. And once you find that process and be able to fine tune it, you can pretty much manipulate the gravity flyer however you want.
Yeah, it's totally different, man. You have to.
So, are you kind of comparing the flyer to like a capacitor plate?
It's
the middle plate isn't it?
It's sucking everything in like a capacitor. But it doesn't have the limit that your capacitor does. The field keeps growing. That's the thing. Because you got to remember this. You have the Tesla coil field here. You have high voltage on the inside of the field. As the high voltage grows, it can push that Tesla coil field a little bit out. You know what I mean?
It's kind of like a capacitor that's not contained.
That's right. So
the flyer is not contained by an insulator. That's why it keeps growing. Maybe the air is the air is taking.
I'm converting the air.
The air is becoming part of the flyer and its capacitance. It's growing into the air. The capacitance from the flyer, because if it were contained, it wouldn't be able to go out into the air and build capacitance with the air also.
Yeah. So 2 things you have to do: you have to create a gravity well, and you have to be able to convert the air. And when you build the bubbles on this thing,
or the atmosphere,
you have to be able to convert that air inside the charge. And it creates, by the way he designed it, it creates its own gravity well. Okay, it's pulling in, it's also pushing out with the 2 different fields going on. Then on the inside, it gets charged. So you're removing yourself with that resonance from the actual, earth itself. you're pulling yourself out of that field, and you're creating
Oh,
a
so
field
you're
around it.
isolating yourself from the magnetosphere.
Right. So
Oh,
everything flows around it. It's like
oh,
snow.
that makes
Snow comes
sense.
down
That's a good way to
as it,
picture it. Okay.
yeah, as it
Because
rocks,
she's oscillating.
goes
You're
around it.
oscillating. You're oscillating at a different frequency than the Earth.
Huh.
Yeah.
300
Yeah,
and some
there-
kilohertz, right?
I'm not allowing it to push down on it. I'm not allowing things to build up energy on it. So it's not allowing it to push down on it. That's the key.
There was a live stream that Bob Greenier was doing earlier today. He might be still streaming, but there was a part he was talking about the reversed alien replication vehicle and how it relates to the fractal toroidal moment. And if we have time, I'd like to show you just a small clip from it, because he was talking about, the process he thinks these things lifted, and it had to do with a lot of similar subjects and topics we're talking about here. And the alien replication vehicle, I think, was split up into like 48 parts, and that number was very specific for a reason. And I don't know if you're interested. I'll find the clip and I'll play it in a little bit.
Yeah, if you can pull it up, by all means, do it. I always love clips of different cool stuff, man. So I actually have a clip here in a little bit, man. I gotta find it though. So if you guys could do this for a minute, I will. I'll look for it real quick.
I'll pull up, because I got the Martin Fleischmann Memorial Project video right here. Just need to find it in the video.
What video are you looking up? Oh, the camera froze again.
Oh, Benny, we got to do something about your camera, buddy.
It looks like Max got the Max Headroom effect.
Did you want me to try?
There you have it. Oops, sorry.
So what's your explanation? I mean, what do you figure? What is causing this? I mean, it's like the weirdest thing.
So hold on, let me play it and we'll show everybody. Watch down at the bottom. There's going to be a rumble in the bolt looking thing down there, and you'll see it'll vibrate the whole table. Watch.
Does it happen when your arm's not resting on the coil and only your fingers are pressing the wire?
It happens when you walk away. I walk away and I tape it, right? Walk away for a few minutes, come back. I start wrapping it again, just going that same speed, and it starts to happen. And it's only when you're in the middle of the winding. So it's only like you have wound half of this thing, and then it'll start, and then it'll stop at the last 4 to 6 inches of it. And it absolutely rumbles the table. I thought there was an animal or something underneath my table.
Yeah.
Something just
the middle of the winding. When it happens in the middle of the winding, you got two coils that are evenly. They're in series, but they're in series, the two coils, but they're evenly.
They don't have the same amount of wire or anything like that, so they don't.
No, but when you got two coils that were in series there, right?
Yeah. So I'm building up.
When you reach a certain series impedance between the two coils, it probably self-resonated at that certain differential in resistance between the two coils that were in series.
Yeah,
when you reach a certain differential in the resistance between the two coils, maybe that has something to do with it. That's interesting.
Well, it was able to transfer the power. So when you saw my hand moving, again like this, I'm just
Transfer
doing
power
this.
from where? From where? It wasn't hooked up to a supply.
It's building up charge in it from my hand. So it's no different than taking a PVC pipe and rubbing it with a cloth and getting charge out of it, right? You've all done that for static electricity.
Yeah, but it's magnet wire. It's insulated.
Yeah, I understand that. But charge transfers with heat. So again, just understand what I'm saying.
Okay.
When I walk away from it, okay, I remove any heat from the system. When I come back to it, my body heat brings it back. And then I transfer that heat through the next couple times that I spin it. It converts a charge into magnetism, which then shoots the signal over to the other coil.
I think
and
it's the
shakes
vibration. I think it's your finger pressing, causing that vibration of the wire, and the vibration split between the two wires on each end, the series wires, and vibrated because you were at the right resistance between the two wires. And you said it only happened when you were in the middle of the winding and you evenly split the two wires.
No, I'm not disagreeing that it's because of the two coils. What I'm saying is the charge has to build up first.
I think it's caused by the vibration of your finger pressing and possibly your arm also, and the vibration of the coil rubbing against your fingers. Not so much heat, but the vibration, the little tiny vibrations.
I disagree. In order for it to transfer, it has to have heat to change it into a magnetic field instead of a charge. And it's a transfer that will allow it to go.
I agree. You can give a coil heat, and it will induce a voltage. Yes.
No, well, that's what I'm saying. That's it. It's just energy switched. You're switching energy. You're going from heavy charge to magnetism. And when you
can do the
it
same
creates
thing
enough
to a
heat
coil
to shoot it
vibration.
across. Yeah, it gives it enough amps to push it to the other coil. Is what's going on.
I'm just saying, we electrically vibrate coils to transform voltage.
No, I agree. I agree.
Not heat going on there. It's all electrical vibration. No heat. The heat's just part of the resistance.
No, that's not the way electricity works. Heat changes your voltage in amps. So when you put in heat, you're putting in amps. And without that heat, you don't have a lot of amps. Okay.
Oh yeah, the resistance of the coil determines how much heat.
And I'm also tweaking the resonance frequency as soon as I apply the amps. As soon as it goes from charge to a magnetic field.
Tweaking. What do you mean by
tweaking? It then applies the amps into it.
When you get to the resonant frequency, why do you need to tweak it? You're already there.
Because it changes every time you change the amps and volts. The frequency always changes when you change an amp or a volt.
And you got to keep moving it around. I get you.
No. It's a self-resonating system. Once you get the coils right to the right amount together, like you were saying, then you're just flipping energy charge. So you're flipping the charge on the pipe over from a charge to a magnetism. Every time you got to think of magnetism as in the amp in the circuit. The amp goes through the wire. The voltage goes on the outside of the wire. It has something to chase now. It can now transfer. It can't transfer without that amp. Even if it's the smallest milliamp in the world, it has to have it to transfer.
Right, exactly. You need at least a nano milliamp to get that voltage
something
through. Right.
Yeah, I'm not claiming I got the world here, man, but it was just a cool effect while I was winding a coil. I thought it was awesome.
That's what's good about the high voltage systems is that, even if you don't have amps to work with, but you have at least one microamp around, you can get it to the other side.
Yeah. Well, the coolest thing is the frequency on that has to be so low. Like, there's no way it could be a high frequency because you just got me spinning a pipe. You know what I mean? So the frequency itself is probably single digits in the hertz, 10 hertz, something like that, 5, whatever. It's not real high. And if you think about the Tesla earthquake machine, he did it around what? 8 hertz or 18 hertz, somewhere around there, something insanely low. So it kind of tells you where this world is. We're not in the kilohertz. We're in the hertz, real small hertz, change things big time in, Earth.
And you're trying to stay outside that oscillation field by going in the 300 kilohertz range.
No, I'm going right into it. Are you talking about ZVS?
Yeah, the flyer. You're trying to stay outside the Earth's field
Oh,
or inside of it, but
we're creating a bubble inside the Earth's field that blocks all the waves that come down that apply pressure on you.
with the 300 kilohertz signal.
It it's hard to say. Okay, yes, it's going to
Yeah.
be in 300 kilohertz. Yes.
Around there or whatever.
However, because the gravity flyer is a self-resonating system, it will correct itself automatically. So whatever the frequency is in the center plate is the frequency that's going on the whole thing, including the Tesla coil, where it'll take over the top 4 inches of your Tesla coil every time. And that'll apply the frequency to everything because of the beat rate. Yeah, the beat rate's going to take over everything, and it's going to make it a self-fixing system. You won't have to change the resonance in it. It'll change itself based on what you're doing. So you just got to be cautious of what you're putting into it. Once you do that, it has that to work with, and it'll self-apply whatever it needs to.
So what do you think is doing the self-resonating, the transducer?
No, that's just a little disc. It'll
or the
flip
geometry.
frequency. It's the center plate.
The center plate.
Everything comes back to the center plate. Everything resonates based on that, because when you spin your disc, it puts a resonance in your center plate
By spinning.
by spinning. So when you slow down or speed up the motor, your resonance in your center plate changes. Because it's pushing back on your coil, your Tesla coil, it then puts that frequency in the top part of your Tesla coil.
So you're using the rotations of the center plate speeds, controlling the speed on that to manage your
of the top and bottom disc, yes. Not the
so
center plate.
So you can control the rotation speed on that?
Yep.
Oh, how did you do that? You're doing it with a wire, or
no? It just has motors to it. You just turn the motors, and then if I change the volts and amps, if I change volts and amps on it, I can change the top by about 0.5 volts, which is enough to put it in resonance and take it out. So, yeah, it picks up more energy when it's in resonance. Trust me, and you can see it clearly if you know what you're looking for, and boom, you can start pulling energy into this thing. But you can't do it without it. It won't pull it in.
The whole reason I never mess with Tesla coils because I don't have an application for them. What do you do with them? They're just making sparks. What other than that? What do they? So the Graviflyer thing is like, at least that's an application for a Tesla coil, right? Or wireless lighting or something, maybe.
Build them all the same frequency. Okay, build 4 of them or 5 of them. Okay, put four of them around the center one. Then put them out. You know what I mean? Just like a square. When the center one goes off, the frequency will be going to those other ones because the frequencies match.
Right, because you're all the same.
And you'll produce energy in each one of those. Now put those into capacitors or batteries. You can now charge everything based on one coil. And that's it. And it's a wireless system. So you never use the energy you pull out. You have to put it into something before you use it. So if you put it into a capacitor, a battery, something, then you could put load on it. You have yourself an over unity effect. That's what you use them for. You know what I mean? It's the same thing they do in the power. They bring potential in. The potential, resonates the coil. It resonates 2 other coils that sit next to it. They pull in that power based on where they are matched at. So they're not exact frequencies to the center coil. They're off. Because they're off, they're not pulling all the power from it. They're only pulling a portion of it. And frequencies like either you hit it dead on or you have to be close. If you're way off, it'll be like 2 ships passing in the night. They'll never see each other. They'll never interact. They have to be within a certain amount from each other. So you could do all kinds of cool stuff with this.
Wasn't Tesla using his Tesla coil to transmit to those wireless boats that he made?
I don't think he was using Tesla's coil. He was using a radio frequency thing. He basically made a remote.
A coil.
It was radio frequency.
Yeah, he was.
I don't think there was a Tesla coil in that at all.
Well, this controller had coils in it.
I don't know. I'll have to look it up.
I saw the diagram. It had little coils that
It could have been both.
you would move
Could have been
a
both a Tesla
knob
coil and
up
using
and down
radio
the
frequency.
coil, give different voltage, and it would, because the coil on the boat was the same dimensions, and the signal would reach the same coil on the boat.
Right.
It's like-
I don't know if the coils are Tesla coils.
No, man, they weren't Tesla coils per se. Like
Right.
big-
That's what I'm saying. You said Tesla
But he
coils.
was he was using coils though to transmit to the
Okay.
boat.
I'm good with that.
So
That's
it's a
just-
similar,
Him
concept.
putting in a Tesla coil and a remote didn't sound right to me. Sorry.
Well, his little
That'd be
controller
one
had
heck of a trick.
his little controller had a bunch of variable coil and variable
understand.
inductors in there.
So it could change the frequency real quick.
I'm not
Should have
sure.
certain frequencies it follows, yeah. But that's what I'm saying. It's like an AM radio. When you hit it, you hit it. When you're a little off, it still hits it somewhat. When you're way off, you're nowhere close. And that's what Tesla coils do in order to transfer power between one and the next. They have to be at the same frequency. So that's it.
So you have to tune your flyer to the coil.
I don't have to tune it to anything. It's once it works, the gravity flyer, like I said,
I'm sorry, tune the coil to the flyer.
I just have to tune the coil actually to the ZVS, and the flyer will take care of the rest. That's it. And then you watch. Once I push that button and I change the frequency real quick, it'll push back on that coil. That's the trick. It goes from a kilohertz to a megahertz frequency as soon as you push the button. So it pushes back on there, causes that number one coil to heat up and start to hum. And then when you release the button, boom, it all flows right back into the gravity flyer in one big punch. And boom, there we go. So, yeah.
So once it punches through to the graviflyer and it forms an anti-gravity well or bubble, and then it's fine. Like it doesn't need that punch anymore. Like it's kind of sustaining at that point.
It's a wireless link, a radio frequency link.
It has to have enough punch to break it free from the earth. You have to be able to flip the charge
that's
to
what
magnetism.
Okay.
That's it. You have to be able to flip it. If you can't flip it, it'll suck to the ground. And it's continuously sucked into the ground. Once you flip it, it'll pop. Then it's a whole new ball game.
Flip the switch, you mean?
Yeah, once you hit that button, okay, it shoots a megahertz frequency down the center, okay, and then it'll pop it off the ground.
Do you have a diagram of this button and what it's flipping? What is it?
Yeah, it's an ultrasound circuit. I have it on my.
The circuit. You're flipping the switch on the transducer. Okay.
Yeah.
Once you flip the switch on the transducer, it switches to megahertz. Okay.
Yeah.
And then it breaks connection to the earth when you do that. I see. Interesting.
That's the goal. Yep, that's it.
Something you would only know if you were replicating.
Yeah. Because he doesn't tell you the specific information you need. So he doesn't give numbers because he doesn't track them. And the only way he tracks it by the sound. So you got to pay attention. So the big key is, can you get that Tesla coil, that number one coil, to get feedback in it? If you can't replicate it. That's the whole key here. The ZVS circuit works great because it'll take the abuse. My little transistor with all diodes in the world would not take the abuse. It just refused to do it. Put a snubber circuit on it, still blew it. Okay.
What happens?
Does it blow it out like immediately, or does it take a little time for it to just fry
They'll blow it out as soon as I hit the button.
Just as soon as.
What happens when you flip the switch and it breaks connection, and what happens to your CVS and your source side?
See this? Okay, so this one on the ZVS,
you get a drop in volts or something.
I'm pushing a frequency that it doesn't like, that's not its oscillating frequency, back into it. And I'm doing it with a ton of power. So I'm forcing it in there. It's like trying to shove something in the trash can, right? You're pushing. And eventually when you let go, the lid comes up. Sorry. The lid comes up and it just explodes out of there again. That's what's going on here.
What I'm saying is when you turn on the transducer, you should have a small voltage drop just to power the transducer, right? It needs power. But I'm saying that's a small drop. But I'm
Hey,
saying when the
but
thing switches to megahertz, do you see a large drop in voltage on your source, or just it stays just like a small drop when you turn on the transducer? Like there's
it
no.
it backs up.
So
Okay.
you get a large voltage drop on the source when you turn on the
You
transducer.
get well, it's like when you resonate it and it's not resonating properly, it backs up into the power source. Okay. It's the same thing going on here. Okay. So even when you protect your power source, your coil can't handle it. So when you push back on it, you're going to start frying wires. And trust me, I've smoked up a lot of them. Okay. It'll fry that wire. Okay. Completely fry it off. And I don't care what gauge you put in there. You could put it in there, cables from your car. I'll start frying it because it pushes back so hard, it's lighting it up. That's what's going on. It's pushing
You
hard,
mean
man.
the wire inside the tube of the coil of the Tesla coil?
Yeah, it's pushing the energy of the whole gravity flyer back into this coil. That's what's
It's
going on.
it's
It's like
coming out the tube,
yeah,
magnetic field
Because
or
it's the
whatever.
gravity flyers completing the circuit.
yeah, it's forcing it back in there. I'm forcing a frequency that's bigger than the one it has
And that's
back
causing
into
your
it.
stuff to burn out when that happens. That event there, I see.
That's why I'm switching.
You can't you well, that has to be coming from your source. That surge of amps.
It comes from
If it's you would know if it's hold on. You would know if it's coming from your source if you see a large voltage drop when that happens. If you don't, and you're still burning stuff out without a large voltage drop happening, you should have a camera watching that voltage at all times on your source. On your source.
it's not coming from the source.
I mean, you
The
wouldn't know
source
unless you're
stays the
watching
same.
it all the time. The
No,
drop
no,
will
no.
be quick, and back up.
The source stays the same. I'm telling you that right now.
Okay.
It's pulling energy,
And it's not coming from the source. That's definitely,
It's
that's
pulling it from the ground.
right.
It,
Yeah, you'd have to assume that if you don't see a large voltage drop on your source side, you'd have to assume it's coming from somewhere else.
because it's a capacitor to ground, and I've completed the ground circuit.
I'll be right back.
Wow. That in
So,
and of itself is very significant.
well, yeah. I mean, why do you think I'm doing this, man? We got to create the right circuit so I don't have stuff blowing up on me continuously.
No, that's brilliant, actually. Absolutely wonderful job, Nathan. I like the work you're doing.
Yeah, it's turning out good, man. We got something going here.
And with all those 3D printers you got, you print out some stylish parts too.
Oh, thank you. I'm trying. You know what I mean? Sometimes
Yeah,
I get it right, sometimes I don't.
The first one, the first gravity flyer I looked at, it was a good, like concept. And then the second one that I seen, the more recent one, I was like, wow, this is a nice piece of equipment right here. I don't think I could replicate that, not easily at least.
Well, if you got a 3D printer, you can. I put all the STL
Right.
files for free. That's all.
Yeah,
it
no,
takes.
at some point I do intend on getting a 3D printer. So maybe I'll put this on the books for a future project. This is a fun one for sure.
Hey, Nathan.
Yeah.
How much are those printers? The one you're using?
Depends. Usually they're about a couple $100. But if you go on like OfferUp or something like that, you get it for like $80 to $100.
And the files that make the parts, they're universal for all the printers?
Yeah. You just have to have the right size. So
it don't matter which printer I buy?
No, just buy one that says 310 by 310 or 300 by 300 millimeters. It's a bed size, and you'll be in good shape. If you buy something smaller, you're going to run into problems. So on the general basis, everybody usually makes files to fit in, like a CR10. That's what I have, a bunch of those. So, and then there's tricks to make them faster. I could take a 14-hour print and do it in 4 hours. So it all depends on, what I mean, what you know.
Got it. Yeah, those printers are priceless. I mean, they just make anything you need to make,
Yeah, well, it's handy when you go to build stuff like this, isn't it? I mean, you need everything.
Mm-hmm.
I heard they got printers now that do make metal parts out of metal.
Yeah.
Yeah.
I see people print chocolate.
I've seen that too.
They're crazy, man. People just get crazy with this stuff, man.
I know.
They got those. I have never used them, but they have the other ones that you put chemicals into, and it just makes them. I don't know what the heck they are. I couldn't figure it out, so I didn't bother buying it. So, but they say they're real clean prints, so I guess it's good. I got rid of all the gas stuff in my house. My son gets real weird about any fuel in the garage, so the last thing I want to do is bring in something else, some chemicals, freak him out. So
understandable.
Yeah.
We got some new comments. Let's see what's going on in the chat.
Copper infused filament. I have iron filament like that. Yeah, like you're saying. I have the iron stuff for making out generators and motors and stuff. So it prints like, shavings of iron inside the filament. So it'll actually pull on a magnetic field to it. That's pretty cool.
You can print filaments?
Yeah, the filament's what goes inside. That's what the plastic is. It's called filament.
Oh.
And it'll, like I said, it's got iron shavings in it. It'll actually make a magnetic core in there. It's pretty cool.
Oh, you could do that?
Yeah.
You mix the iron with the plastic, or?
It already does it for you. You just buy it.
Oh, and you can make a core.
Yeah, it's not going to be like your soft iron core by any means, but it's going to be a little bit instead of just plastic.
Oh, so it makes it a harder material or whatever.
Yeah.
Awesome.
That's cool.
So that's why they have that, so you can make it more material, more hard or whatever.
Oh, nice. Yeah. I didn't know you can do that with the. Oh, cool. No, I'm learning new features with this StreamYard.
You push the button over the top of it, and it'll show the people what they say.
Yeah, that's neat. Okay.
Nate, how come you don't drive your center disc with a little pulse motor or something? You can speed it up and slow it down the same as any other motor.
Yeah.
You're using a regular DC shaft or whatever?
Oh, I'm using a PC fan.
A
That's
PC
what I use.
To spin the disc.
Yeah.
You just glued it to the fan.
You know why? Because they're weak. When I change
because they'll give way or whatever.
When I change the voltage on them, it slows them down. Or it'll speed them up. Yeah, I do. Because your lower disc, because it has magnets on it, takes longer to get around, right? So the trick of this whole thing is you run it on one driver. Now I'm going to control it with volts and amps. Because the upper one slows down and speeds up so fast, and the lower one stays because it has that force put upon it, right? Now I can get them to the same speed. I don't have to change them individually. You got to remember, it's a self-fixing system. It automatically fixes itself.
I thought there was only one spinning disc in there.
There's two.
Two.
So,
but he's saying the bottom one is spinning at a constant rate, and he only has to adjust the top one. Then once it's getting in resonance, it just kind of like.
Are they counter rotating?
Yeah.
Yes. But you got to remember, there's magnets on the bottom one, so it's going to put an eddy current in the top disc. Okay. So just understand this. There's a whole flow here. When you start messing with them individually, you start screwing stuff up. They're meant to be together. They're meant to have the fields force them to change. When you change
like it's not about the part. Yeah.
Sounds like the eddy currents are being
controlled
by the two spinning discs.
Yeah. When you change that, you're changing the fact of it staying in the right spot. It's no longer self-fixing when you do that. You have eliminated that from your system. Therefore, you have ruined it. It has to be self-fixing. That's why he built it this way. It has to be able to fix itself on frequency and everything. Okay? It's going to go into the right spot, stay there, and be good. As soon as you start playing around, you start changing everything, you start really ruining this whole project.
Does anybody know how long Does anybody know how long Alexei has been working on this thing?
He worked on it 10 years before he got it to work.
And what
He-
was
so
his
he started it
background?
10 years ago.
More than 10 years now, because he's had his videos up for what, 5-6 years at least, I think.
So his concept was going on for over a decade.
Yeah.
What's his background? Like what's his like
don't
what
know.
you don't know?
Russian. He's Russian.
It might be some kind of scientist.
Yeah, I don't know.
Well, obviously.
Well,
He's-
could
Well,
just be
I
a
mean, like,
backyard inventor. Who knows?
Like some kind of important industrial scientist or something, you know?
well, a lot of Russians and Eastern Bloc people have a lot of electrical skills in general. It's just common knowledge over there, more common than the West. Tesla,
And, it
is from that
seems
same area.
like they have a more open mind with fringe science.
Yes, they
like
do.
I'm not too familiar.
It's
Yeah,
not
I'm not
fringe
too
to them at
familiar
all.
with it, but yeah, it's not taboo. It's
They don't see it
it's
like
just
that.
right. So you have more people, I guess. I imagine like looking into these things. So
Middle Eastern,
that's
countries and stuff.
and that's interesting because
The Balkan areas. The Tesla was from those areas, the Balkans, and it's like like the Rus areas, Balkan areas. They're all like same type of language, similar language.
they
And
have
all those people have, like an intuitive, it's like common knowledge. Electricity is not uncommon. Like here, you teach, everybody can change a plug over there, or a switch.
I love
not
their
like here.
videos when they start messing with electricity over there, dude. They're absolutely hilarious. I can't understand a word they're saying, but I love the videos, man.
Oh, I understand. I understand those videos. I speak Bulgarian, so I can
No. Well, there
tell
you
what
go.
they're
nice.
talking about.
So
if you ever
you
want
don't have
if you got a video, you're trying to get help.
Oh,
with
if
it.
they
You
hit
can
you
also
up because
translate.
he's got a lot of them that I don't understand.
Yeah.
Yeah, I understand
There
half
could be
of the
some
words.
key information in there. Yeah, so there could be some key information in there for sure.
Yeah.
I mean, you could translate Russian though with the audio translator, doesn't it work on
Yeah,
YouTube?
it translates it. It likes to tell you that you have a sandwich when you have a coil. It's told me that I have bananas for ears. It doesn't quite get it right.
Well, send me the
Well,
video
I don't-
you need help with, and I'll listen
Yeah.
carefully. And try to...
I don't know which part we're right and which we're wrong.
Yeah.
You know what I mean? I could have
Yeah,
bananas for ears, maybe, but the coil wasn't right. I don't know. So I watch it on mute and just see what he does. So yeah, they don't get it right. They always try to tell me I have ice cream in there too. I just don't understand it. Always with ice cream. Anytime a translation video tells me I have ice cream.
Ice cream. Right? And Google AI can't hear the.
Trying to get me into
correctly.
the freezer to get some ice cream, probably. Somebody over there translating is hungry.
Subliminal messaging.
Yeah, that's what happens when you have your location turned on your phone. You drive by a McDonald's, you get the AI
Right,
does
yeah.
something like
Or you start talking about it too. Honestly, I've
or you start talking
had
about
many
it. Like I just
experiences.
did.
Yeah, start talking about a certain thing, or you have an app installed for what you're talking about, and it'll give you a notification. Hey, you hungry? Like, come on, what the f? Like,
Yeah,
I know,
you-
like this isn't even subtle. This is obvious.
They read your phone's location, and then they see when you're driving by one of their stores, and that's when you get the reward. And if you got the McDonald's app and you got notifications on, you'll get a notification. Hey, would you like a McDonald's?
I feel violated, Mike. I feel violated.
Hey.
Listening to everything.
Taking advantage of you over there.
I turn my location off. I only turn it on to buy food at McDonald's.
Oh,
Because the rewards they got the rewards program in there.
Yes, I mean it's unfortunate, but yeah, the rewards programs for some of
It
these
doesn't work without the location turned on, though.
Look, like you need it. You know exactly where they are if you're in the rewards program. You're getting flyers at your house, probably telling you to go visit them.
Oh yeah, you sign up texts and stuff. Yeah, I hate that.
I remember once I was listening to Pandora. You know, I don't have the paid version of it, so I get ads on Pandora. I'm driving, and I had my location on. I don't remember which ad came on, but an ad came on of a fast food thing I just drove by or whatever, or was about to drive by. That's how I remember it. And the Pandora, I had my location on when that happened also, and the Pandora was reading where I was, and waited for the next ad to come on, and chose the ad that of the restaurant I was about to drive by.
Oh wow.
They
Nice.
do that. It does do that.
Yeah. Yeah. It's all automated. And it's not like some people think
is.
they're actually a human listening to everything. No, it's all automated. They're
They put a
listening
lot
to
of
tag
effort into
words,
marketing.
keywords. Yeah. But
That's
it's there's an algorithm for everything. It's all automated.
Yeah, but when you realize that's what's going on, though, it doesn't work. It's when you don't realize it that it works. And I realized it, so I didn't go to the restaurant.
You
I
definitely
just turned
win.
off the location.
You definitely win. Don't lie to us. You have the rewards program. You definitely win.
I never have the location on, and when I turn it on briefly, that kind of thing happens.
Mike goes, I need some fries, man. Let's turn on this location. That's what it is.
Da-da-da-da-da. I'm loving it.
I'm going to.
Oh,
I got
crap,
to. I
I'm
got to
gonna get hit with a
go to an address.
copyright.
I'm not sure how to get there. I turn the location on, and that's when the thing happens.
Oh, man.
I
He's
get
going
marketed.
McDonald's to McDonald's to McDonald's.
And, they're pretty good at too. They don't market you ads at places you don't shop at.
Yeah.
They only market, to ads to places they know you've been to. That way, you're more likely to go there again.
Hey, guys, then you got that Tesla coil where you can show us the gas tubes and stuff?
Yeah, I can set it up right now. Give me 5 minutes.
All right, go for it, man. Set it up.
All right.
We're all here about Tesla coils, man. We're talking McDonald's. Let's fire something up, man.
The only Tesla coil I got is those little handheld zappers
Oh,
with the those 3.7 volt lithium batteries.
oh. Yeah, set it up, Ben, then I'll set up mine again, and we'll just light some stuff up here. Just excited that the stuff works, man. So
That is the most popular use of the Tesla coil today, is the zapper. Did you know that?
yeah, that's what I see all the time.
That's mainstream Tesla coil use right there. The zapper.
But that'll change soon. Wait till I get to working on this thing some more. We're gonna have all kinds of new uses for this thing.
I'm sure before they use it for flyers. What else do you think they use the Tesla coil for? Wireless power, maybe.
Yeah, absolutely.
I think some places have that already running. They're just not public about it.
Well, it could. I don't have no idea. I've never seen it. So
I've heard something somewhere in one of those desert states. They have somebody has a wireless system running for lighting from a Tesla coil thing. Saw a documentary somewhere. They were using the one wire thing.
okay.
It was on the one wire, and they were getting the lights to light up out in the middle of some land that some people owned, and they didn't have power out there, and they had to figure something out. Just to get lights, not necessarily running motors and stuff. But they used that whole Tesla coil thing to make the lights, and they did it with the one wire thing, something like that. It was one wire, and the lights were all in series.
Okay. I'll have to check that out. You have to send me a video.
With the wireless high voltage signal, you can get your little amps to all the lights very long distance wirelessly.
Cool. We'll have to try that. Let's put these things to the test, man.
Of course, then there's your frequency. You choose whatever frequency works best, but it's still high voltage and it's still wireless.
Well, if it's wireless, the frequencies have to match.
Right.
They don't match. You don't have wireless.
The transmitter and your receivers have to match.
Yep, frequency works like two ships in the night. If you don't have the frequency right, they'll never see each other. So, yeah, Master Evo. Have you watched any of his videos?
Yeah, I watch all his videos. I don't know if I'm getting the notifications anymore, though. I don't know if he's slow on
If I'm
making
thinking
videos.
of the right guy, we have a Tesla coil with a pulse coil in the center.
Pancake coil, yeah.
Yeah, the bifilar in the center.
Mhm.
Love that video, man. Probably the best one he's done.
I'm still
Absolutely.
trying to, tune in to exactly what he's doing there, but it's
So
so
it's not much
complicated.
different. You're just pulling a coil in the center and it's pulling in energy.
He's transmitting and receiving.
Yeah, he's transmitting, receiving. He uses ZVSs to run his stuff.
To transmit.
Yeah, to put it in there kind of like this, but it's a different ZVS though.
And he's close range receiving.
It's on the coil. It's the extra coil is on the coil. He says it's a Tesla coil. Tesla designed it and he built it.
Tesla
And he's doing
pancake.
research into it. Yeah.
He's getting into detail on the type of waves that the pancake makes. It's not the same as the standard Tesla coil.
No, it's not. He's just pulling a pulse out of it. So it'll come out in a pulse. It's like taking energy and putting it into a capacitor. It's a pulse. You're just pulling energy out.
Remember, the waveform is also completely, I don't know, different. I don't know what the waveform
It
is.
comes out as potential. It's wireless, so it's
The geometry of the waveform on a pancake is like totally different than a standard Tesla coil. Is what I'm saying. So like that's the whole. How do you capture all that geometry into another stator? So,
Well, you're going to have to because that's the way those things work. It's like playing pool. How do you put it off 4 banks and still make the shot? You better understand your geometry.
right,
So,
that's where I lack.
No,
I am not an artist.
I'll shark you in pool any day. I'll do it with both hands too. I'll shoot left-handed. I'll shoot right-handed. And I'll still do it. I'll still bake it and hit it.
I'm pretty good at pool. I was referring to geometry. I mean, art and stuff.
Well,
drawing and all that.
Use geometry and playing pool.
No, I mean the skill of drawing the geometry. And understanding all the.
Oh, they got computers for that.
That's what artists understand. They understand that better than most people. Like all the shapes and how they come together and stuff like that.
Yeah. You got to start seeing things as lines. Quit looking at the whole picture. Just look at a certain line and replicate the line by line, and then it'll work out. I can draw just about anything, man. So
what happened to Ben? He got dropped out there?
He's still working on his Tesla coil.
Oh, he's trying to turn it on.
Yeah, I was kind of hoping since he knew it was a Tesla coil day that he'd have it ready, but
yeah, I have more fun with motors and stuff like that. Like I don't know why, but I just prefer to like get locomotion going on, and if it's either that or solid state power generation.
okay, hold on. We got a chair here. Benny's back. Well, okay. He's got a little one. All right.
You ever heard of the Hendershot generator? Nathan?
Henderson, no.
You gotta check that out.
Henderson.
There's coils in there and capacitors and magnets. It's solid state. It's supposed to generate 300 watts.
There's no rotation of magnets?
Nope, solid state. Whole thing. The Hendershot generator.
Hendershot. Let's look that up.
Yeah.
Oh, there you go. Let's see if he's got this thing going. I think he froze again. He's doing an action pose to get it going.
Get that Bluetooth camera, Ben.
I love that. I just love it frozen when he's like, oh, you know what I mean? Like superstar pose. We're getting in there.
The sparks froze his camera.
Oh my God. It's still frozen. He needs to fix that, man.
Is he using a Bluetooth camera or a wireless camera? Oh, there you go.
I have to ask him.
maximize his window?
Oh, here we go. Hold on. Let's take us out. I got no audio on that. Oh, wrong one. Was that one? No. I saw it light up. Let's see what he's got.
Said there was a gas tube on that or something?
He says he's got one. Okay, I'm going to remove us now. So, okay, I'm not seeing anything. Like he's got a light bulb to it, but I didn't see anything light up. Well, he turned it off. Okay, here we go. Well, that was cool. KR, what's that?
Nate, you ever try getting more range on your fluorescent bulbs with your coil using different frequencies?
Whatever it resonates at, yeah, I look for the distance in it. That's one of the tests I always do.
So you can't choose a different frequency to resonate your coil at?
No. It resonates where it resonates. That's where you set it.
I mean, you can't. You get a resonant frequency, but you can jump up in octaves and still be resonant.
No, you're not changing it. Hold on, he's got another one. Hold on. Okay, that was neon. I saw NE neon. No, that one.
Different gases.
Yeah, that's cool, man. I got to get some of those tubes. That just looks awesome.
What is the range of your ZVS? How many? What's the top? Does it go more than 300 kilohertz or what?
Right now it's at 371 to resonate.
But you can drive it higher than that, your ZVS?
I could change the resonance point. It changes the frequency, but it'll be out of resonance.
No, I mean, forget about the coil. The ZVS, what is the range on your frequency on that? What can you turn it up and down? What's the range? 10 to 100 kilohertz?
250 to 400 kilohertz.
So it starts at 250 hertz and reaches 400
Kilohertz. No. 250
Starts at
kilohertz.
250 kilohertz. Yeah. And lands at 400 kilohertz.
Yeah, that's the range, and you got to find the frequency of your secondary in that.
Right. So if you had a ZVS that had a broader range, you could do more experiments.
Right. So we're looking into changing that so we can get a higher frequency out of the ZVS circuit. So
why do you want to use a ZVS? You can't use a function generator?
It's not the same.
Why?
Because
it's not an AC signal?
Yeah, hang on. Hang on just a minute.
But it's kind of risky to blow up a $300, function generator. I get your point there.
Yeah, hang on. That one's helium. That one turned out good. Yeah, sorry about that. I can't get the button to put his in a big picture. It won't do it.
No, it went to the big picture just now.
No, I mean it won't leave us in the picture right, does it?
Oh.
Because he's not putting it on there, so it's not flipping the right way. I don't know how to change it.
His mic is muted.
Yeah, I don't know what he's doing. But anyway, yeah, Tesla coils have to work on a certain frequency. They have to resonate together. You can't just willy-nilly change the frequency in them. It doesn't.
You did on StreamYards. I was like, why is my mic not working?
There you go. It's working now.
Okay, yeah. So I couldn't get any of these lights to work. I think a couple of them might be dead. This is the one that it came with. It might be dead. I don't know. It's not lighting up. It used
to light up the gas inside. If you don't have no gas in it, won't work.
That light don't have any gas in it. Then.
Yeah. Okay, that makes sense. All right. So I have a whole bunch more gas tubes.
That's a car light.
This one's xenon. Yeah. The it's probably got like a little bit of argon in it.
You think the car lights do? They put gas in car lights?
They put a tiny bit of argon and sometimes mercury vapor, and the mercury vapor oxidizes the coil inside, so it pushes away the oxygen.
Protects
so it
filament.
It protects the filament pretty much. I did a video on it. If you watch Divine Science Special Fun with Plasma, there's a little bit of a factoid in there about it.
Ben, how much was that Tesla coil kit with the neon gas bulbs? Did they come together?
No. The gas tubes were separate. I can't remember how much the gas tubes were. They might have been like there were different like kits. You can get like 3 of them, but I got the full like set. There's like 8 of them, 7 tubes or 8 tubes. I don't know how much I paid for the tubes. It wasn't more $100, I don't think. But the Tesla coil was around like $80, I believe. And this was all on Amazon.
If I'm going to spend time with a Tesla coil, I'm going to try the long distance wireless lighting with the fluorescence, with the different frequencies and stuff. I think that's what I would probably do with a Tesla coil. Did you guys try to get like, at least 50 feet or something? Get that bulb.
Great.
Good luck. Yeah.
I'll take all the luck you wish me.
Yeah, you're gonna need it. 50 feet's a lot.
Hey, even if I fail, you
may get a tan before you get.
It'll be fun trying to do that. It's just frequency.
So this is just basic O2. Basic O2 here.
Let's put that up by itself.
And you see, it still kind of lights up a little bit. If I use the coil pickup method, it lights up a little bit more. But it lights up based on the interaction, the bio interaction. See how it's kind of lighting up at the tips a little bit. So it's lighting up just the O2, which is natural, it's not a noble gas. So natural occurring gas. It's lighting it up a little bit just with the bio energy from my fingertips.
That's cool.
Yeah, it's pretty neat.
Can you turn the voltage up on it?
So you can't adjust anything, but there's an audio input. I tried to find my cable, but I'll leave that for
it plays. Yeah, it makes audio, right? It makes sound.
Yeah, you can input a frequency and it'll make sound, and like Nathan said on a previous live stream, it'll do some crazy stuff.
Yeah, you could put the music to it. Yeah, put a little AC/DC in there. That's what I'd do.
Yeah, exactly. So this is just, it's hard to see because I had the lights off so you can see it better. When it's lit up. This is just nitrogen N2. There we go. See that? It does ionize, but it requires you to be a lot closer to the discharge point. You almost have to touch it, it looks like. Again, don't try this at home, children. N2. Yeah, I think this is just nitrogen.
A tank circuit on the coil.
You said what?
Wrap a coil around one of the tubes. Let's say 10
Oh,
turns.
the pickup. Yeah, use the coil pickup method.
Put a 1 microfarad capacitor and like a 10 ohm resistor tank circuit, or even better, if you know what that coil is picking up from that transmitter, the voltage, you can make the tank circuit pulse at whatever frequency you want it to from that voltage that's coming in, and then the coil would pulse right over the bulb at that frequency, and maybe it'd be more effective at longer distance work.
So you just kind
using
of wrap this wire on that tube.
Yeah, so this
wrap a
is
wire,
actually
an induction coil around the tube.
What he's describing is the coil.
Attach a tank circuit to the two ends of the coil, or a capacitor, just a capacitor.
Oh, a capacitor.
Yeah, the right size capacitor, because the coil has certain inductance and also the voltage coming in from the wireless. And then you get the right capacitor on that coil. It'll also it'll be like a picofarad capacitor, I would think, something around there to get you that high frequency.
Real quick, we got a question. How many milliamps does the signal generator put out? Does anyone know?
How many milliamps does a single generator put out? Oh, yeah. It's like half an amp, I think. It depends. Like 1 amp. They're all different. And not more than 5 amps, I don't think. But the signal generators are just there to get you your frequency, not the amps.
Okay, hold on. Benny's lighting something up. Let's
I can't do it for too long because it heats up the tube.
Then you can step up the amperage.
Yeah, that looked really cool, man. That was really cool.
That was CO2. So that was
CO2.
CO2. Yeah.
FCC regulates all those amps outputs on these signal generators for because they interfere with radio and stuff. Communications.
Consider that.
When you get to too high of an amps.
So this one's a little bit of a surprise. This is just air. So this is naturally mixed air. It's got, oxygen, a little bit of carbon, a little bit of argon.
Okay, let's see it.
And look at that. Look at that. Just with natural air, not any noble gas or anything like that. Just with a natural mixture of air. Look at that beautiful color. Wow. And you can see the bio interaction at the tips where my fingers are, how it's changing color. You see that? Right at the tips where my fingers are touching, it's more purple and less pink.
That's cool.
Yeah.
That's like these eddy currents are like spinning up these light fields.
I just love it does the air. It gives me hope. One day see everything.
I never seen air do that. So they had a tube just with air in there because they knew the air would light up.
Regular air, yeah.
Well, you gotta remember, if you take a vacuum chamber, which is basically what that is.
Well, it's vacuumed.
Yeah,
okay, that's why.
It's sealed. Yeah, it's a vacuum sealed tube with the air, and it's 99.
Well, how's it vacuum if there's air in there? It's like
that's what machinery is for, man.
No, you can't have air in there and it be vacuumed, because what are you vacuuming out of there? The air.
Well, it's everything but the gas.
There can't be air in there. It's airless.
Well, That's not true. It's just like the same thing as putting a noble gas in there. You put it in, seal it real quick, and it's in.
There's a tiny amount of air in there. Okay.
Yeah, it's just like the
Yeah,
gas.
so
It's
that's why
gotta
it's
be-
99.99. That like 0.01% or whatever. Yeah, there is but
It's not a true
the point
vacuum.
is but it's sealed and it's as pure as you can get it for that price point.
Right.
the price point.
Gotcha.
That's
Does the
cool,
job.
man. I like all the gases, man. That looks cool. I got to get me a kit. Did it all come in one kit, Ben?
Yeah, and you can buy different. Hold on 1 second.
Oh no, I can't hear him talking to his hand.
Oh no. So yeah, you can buy different size kits. So if you want just 3 of the noble gases, the main ones, the cool ones, you can get those, or you can get the whole like 7 or 8 tubes that I bought, and you can get it right off of Amazon. I'll see if I can find a link for you.
Ben, are you running around in your boxers, buddy? Or you got some shorts on? There's a bunch of UFOs on them.
It's summertime, man. Jeez.
Yeah, it's hot out. No, it's not my boxers. It's my shorts.
Just having fun with you, brother.
It's got NASA on it.
NASA.
These people these days, man, they get on these things and they got whatever on underneath. You never know why they're sitting down.
Yeah, no, it's at least I don't wear my suit and then not wear pants. That's not something I do. If I wear my suit, I go all out.
That's funny. Oh man. All right, guys, I'm gonna set up and show mine again. I'm kind of excited. I want to spark it off one more time. So you guys go ahead for a few minutes.
Yeah, while you're setting it up, I kind of wanted to show you guys the trailer to an upcoming video I have ready to release in about a week or so. It's on a real life flux capacitor. It's a new Divine Science special, so maybe I can cue that up
A
for you,
real
everybody.
life flux capacitor.
Yes.
There's ideas out there for that?
So I don't want to spoil anything, but it's not like an actual device that's been built, but it's something that occurs in nature.
Oh, so there's concepts out there for that.
Oh, for sure. I'm sure there are based off of these.
I haven't heard of it. I've never heard of this. If there's a concept out there.
This is why I'm doing a video, because this connection hasn't yet been made. I'll give you a little hint. It has to do with the thunderstorm generator and some of the effects of the carbon that have been dated suspiciously advanced than what they should be inside the sphere.
Well, let's look at the word flux capacitor. What is a capacitor? It stores static energy. It doesn't store flux energy. So if you make a capacitor that can store flux energy, you have a flux capacitor, right?
Correct.
So what's flux now? That's EMF,
but also the
no?
flux. But also, in my opinion, we're referring to the flux as Marco refers to it, not as the magnetic flux, but the vacuum flux, the flux from the vacuum energy, from the 0 point. So you have all that 0 point energy flowing from the vacuum, from the 0, as Marco Rodin describes, through the number 9, or utilizing the number 9 as the source of this cosmic energy.
And what is the basic concept behind the thunderstorm generator? Is it to pressurize a gas and ignite it or something, or?
So the idea of the thunderstorm generator is basically to have a simple concept that third world countries and basically anybody who is a garage tinkerer can replicate. It replicates. No, it doesn't run off water, but it utilizes water. The point is, it's utilizing the same way that nature utilizes counter-rotating forces.
I've seen that metal bladder that they put the water in, and they somehow heat it up or electrify it. Mm-hmm. Do you know more about that?
No. So the thunderstorm generator has 3 main components. the pre-ionization chamber that takes in the air and ionizes it, and
Is that that
basically
steel bladder thing? Looks like a
no. That's the plasmoid generator. That's the water, the vat of water with the steel wool in it. And then you have the thunderstorm generator, which is the metal sphere with the tubes.
Yeah, that thing. They seem to heat that up or something like that, right?
Yeah. I'm gonna queue up the trailer real quick here. Let's see if I can queue it up.
There's no like detailed.
Imagine a world
operation
where
of these.
time travel is no longer confined to the realms of science fiction.
Time travel.
It's possible, sir.
Where do you come from?
I'm from the past.
Imagine being able to plant crops in the morning and then harvest those crops that very night. Or how about healing a wound with a localized time acceleration device? A device that can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me to imagine this world. A world where time is no longer a constraint, but a tool. Remember Back to the Future? The flux capacitor is a fictional device from the Back to the Future movie franchise that was used to achieve time travel. According to the movies, the flux capacitor is powered by plutonium and generates the 1.21 gigawatts of electricity needed to create a temporal displacement field. Sounds like a giant load of fiction, right? The truth is actually a lot stranger than fiction. Let's explore further.
And you told me the whole story. You were standing on your toilet and you were hanging a clock and you fell and you hit your head on the sink. And that's when you came up with the idea for the flux capacitor, which is what makes time travel possible.
Right, Scott!
Okay, yeah, you can cut it now. I can't. I don't know, for some reason it won't let me cut it. So it looked like it was skipping quite a bit. That's probably because I rendered this in 4K for everybody to enjoy on their TVs if they would like. It's a fully produced video, so it doesn't skip in when you regularly watch it. It's just my internet.
Right on, man. I'm ready when you guys are. You guys ready?
Oh yeah.
Okay, let me set this up. All right, guys, I'm going to take off my headset. I'm just going to light this thing up. Okay, we're on. All right, man. It was rocking and rolling there. Did you guys see it?
Yeah. It's like you're charging the room up with some ions or ozone. Does it
It's
smell like
gonna
ozone?
smell like that if I keep it going. Yeah, I've had worse. I've had this whole thing lit up in here when I do high voltage experiments. You know what I mean? Trying to make some big plasma thing. All right, guys, I'm going to take myself out and turn the lights back on.
Oh, did you want me to show you the clip from the live stream earlier about the alien replication vehicle?
Yeah, I've never seen it.
So they were talking about it might be relevant to the Graviflyer. It's just a quick couple minutes of him talking about it. It's a really long live stream though, so I had to find it.
Alexi?
No. This is Bob Greenier talking about something else, but it seems like it might be relevant.
Any lessons from this build? I'd like to build one. Have patience. Yeah, that's the lesson right there. It's going to look like you hit nothing, then you're just going to hit it. And when you start moving this thing around, you start adjusting for the frequency, just get a clip that works. It'll stay on there. Okay. That's what you have to do. You get one that keeps falling off, you'll be nothing but annoyed. I think my garage has seen several cuss words over the last couple of days from that clip itself. So do yourself the favor and just get a clip that'll stay on there, or bend it a little bit so it wants to bite into it, and then it'll be good to go. Once you have it set, don't mess with it, don't move it, because you'll have to do it again. And make sure your coil stays exactly where it is on the number one coil. If it shifts left or right, it changes the frequency of it. So make sure you lock it in. The next design I do is going to have a groove in it, so it stays exactly where I put it and never moves. And then I can have a plug that goes to this thing, and then I could just simply plug in the one plug and it's set to go. You know, that's what I want. Just set them to where their frequencies are, then plug it in and plug out, and that's it. Never have to mess with everything ever again.
So you're saying the magnetic fields from the primary and the secondary will push each other apart and change their separation or whatever?
Well, okay, the number one coil will move. Here, I'll grab one and I'll show you.
Yeah, it might be easier if we get a visual.
I don't know what that is. Hold on. Oh, why is... Who cares? Okay, sorry, guys. Did that come over the thing? Did you hear it? Yeah, probably. All right. So here it is, right? You see this number one coil, it's not locked in, so it's moving side.
The primary.
Yeah. So, and I can take it out, move it. It's just not in there yet,
So when it vibrates during operation, it vibrates slowly and screws up your signal.
Yeah, so if it bounces, it messes with it. If it starts to turn a little bit as you're adjusting, it starts to mess with it. Everything.
You left it like that so you can fine tune it until you're ready to.
Yeah, fine tune it and then lock it in. Yeah.
Right.
I'm gonna have to go back and edit this video and remove that audio.
That's kind of why we use potentiometers to find the right resistance and then write that down and switch it for a resistor. Don't leave the potentiometer. You just use the potentiometer in your circuit to find your resistance values that work the best, and then replace that section with a hardwired same value resistor or resistors if you need to put more than one to get your value.
Got it. Yeah, we looked at putting a potentiometer in this thing. To control some of it. But yeah, when we go to the resonance version, you definitely need that in there.
Right, you use that potentiometer to find your right signal, and then read the resistance on the potentiometer, and that's you want to replace that potentiometer with the resistor that has that resistance.
Well, not only that, once you figure it out how to break free of the Earth's gravity, then you need to have some way of manipulating it so it can actually be directional. You can direct it.
Isn't that done with the rotating the upper disc?
I'm not sure how you would do it, honestly.
What are you talking about right now? Sorry.
Controlling the direction of it. That's what the discs do that.
Yeah, the height, and then if it needs to pivot to the left or the right, applying maybe some kind of force to the left side of it and the right side of it to change direction.
I don't think Alexei even got that far. He just got it going up and down.
He just got it going up and down, huh?
Right. So he used the two spinning discs are counter rotating. So by slowing one of them down or speeding it up, you can manipulate the eddy currents that are flowing through the whole thing.
Yes.
And control its up and downward.
It doesn't control
What's
it for that.
It's
I would think
interesting
that's
because
what
the alien replication vehicle is basically a giant spinning disc.
You're putting a longitudinal wave into it. When
You got
do it.
magnets on those spinning discs. The two.
Magnets are not doing what you think they're doing.
What are they doing?
So they're only directed up. They can't go out, so they can't make a field. So they're
What are they
basically
there for,
useless unless you're just trying to get to the other plate and you're trying to lock it in. That's
To
it.
transfer, unless you're just trying to create eddy currents in the other plate.
You're just trying to get a lock on the other plate.
So that's what I'm saying. That those magnets on the one disc are creating eddy currents on the other disc.
Yes,
And
that's it.
by slowing down the creation of eddy currents or speeding up the creation of eddy currents, you control the throttle.
You can control the frequency in it, yes, but you're not controlling the up and down value of it. Like the frequency in the center plate, it goes through the piezo disc to create a longitudinal wave that shoves it down. That's what's creating.
So
your
why generate eddy currents in one of the discs then?
because you have to attach the bottom and top plate in a magnetic field.
With the eddy currents.
Right.
And you can stimulate more eddy current development by speeding up one of those discs that have the magnets on it.
Yes, but your
Because that's
speed
how
up
you make eddy
value.
currents.
Yeah, but your speed of value is very small.
Oh, it's not rotating that fast.
Or like 10 RPM, 15 RPM. We're not changing the world here. It's meant to look. It's locking it in on two plates, right? It locks it in. It pulls it out to the edge of the plate, holds it right there. Okay. Then the Tesla field pushes that field out. Okay. That's what's going on. It's creating a field inside of a field.
And
You can clearly see it when he does it. When he does it in the infrared, you can see it. You can see the field.
So then those magnets are just there to generate just a small amount of eddy currents to get the flow going.
Just to get it started. That's it.
Just get the directional flow going.
Why neodymium suck and the earth magnets are better, fringe magnets are better, or Alinco magnets are better. So you don't want eddy currents that strong. You want them weak. You want them to stabilize the field. Then you're going to put a rider of voltage on that eddy current. Is what you're doing. It's riding the eddy current on the outside. That's what the voltage is doing. It's strengthening that field. So that's it.
That's it. We have no idea what you're describing, but it's simple to you. You got it all. You visualized it in your lab there, So
yeah, I know what it's doing.
It's hard to translate what the replicator is seeing in the lab into words.
Well, it's hard because you can't see the fields. If this thing was in a vacuum chamber, you'd see them all day. If I set up a vacuum chamber, I could show you the field. It wouldn't even be hard.
Right.
It's just
you don't think it's center. You don't think it's a vortex field in the center. You think it's going outwards horizontally. That's doing the whole thing, right?
Like I said, the field stays. Once it locks those two plates together, okay, just follow my fingers right here, just like this. It's locking them together, okay? And then once it does that, you're pushing the field out with the Tesla coil field. So as soon as you put power into it, it pushes it out. And it forces that field out. And they start interacting and they start creating more voltage.
And how does that pushing the field out contribute to the lift?
Because once you change the frequency, you're pushing feedback into the Tesla coil. It doesn't like it. It heats up and it'll send the frequency and the voltage back into it in one short jump. Okay. So you're going to take a megahertz frequency and you're going to shove it down that Tesla coil, right? And it won't like it. It's going to want to puke. So it's going to take all that heat and everything from it, shove it right back into the gravity flyer at one instance. As soon as it does that.
And how does that
boom. It goes like this to the field. Okay. Just a big explosion of energy that can't get out. So it changes things. We got a phone call. Okay.
So, and when that jolt happens, how does that? I mean, that breaks the lock to Earth, and that can get you your lift. I see what you're saying. That repulsion, when the coil is rejecting the feedback that it created through the flyer, is what you're saying.
Yes, the feedback is creating. It's not just creating energy that goes back into it. The heat from the number one coil transfers through the number two coil and into the gravity flyer. You're going to create a heck of a magnetic field, is what you're going to do, all at once. That's going to give you a conversion from charge to magnetics inside the gravity flyer, because you're going to flip that field quick. So in less than a second, like a millisecond, boom, you're flipping that field. That's what it's doing. By the way, Todd,
And all
I do put
all that
oscilloscopes on my
magnetic
stuff.
generation is causing heat on your.
It's all the feedback. It's like putting a Tesla coil out of resonance. The number one coil will feed back and burn up every wire you have attached to it.
Same way you heat a piece of metal by passing a magnet over it real fast. That's what's going on there.
Yeah. So basically, it's just a feedback. That's all it is. It's something that you don't want your Tesla
you have
coil.
a magnetic field feeding back to the center of your Tesla coil.
There you go. And with a higher frequency.
Have you identified where it's feeding back from?
Yeah. That's what
The
I'm telling
ground?
you. It's
The ground.
pulling the energy from the ground, from the capacitance to ground, because it's attached to the ground.
Have you ever
It's on
tried
the
not
ground.
starting it on the ground, like starting it above the ground?
And it won't give you feedback.
Won't give you any feedback.
No, it won't.
And nothing, you can't get anywhere.
No. It's
Unless-
completely useless to have it hanging.
So the ground is like turning the key on your car. It basically
It completes the circuit of the capacitor.
interesting.
In order for the capacitor to charge, it must have that circuit. So it has to be on the ground. If it's in the air, good luck. Just
to
good
charge
luck.
with magnetic, not amps, but magnetic field, not converted amps to magnetic field is what you're saying. It needs to charge.
You
Charge with.
have charge that builds up in it. Okay, builds
Magnetic
up really
charge,
high.
not amp charge.
Please just hear me out. It builds up charge in the gravity flyer. Okay, you have to convert the charge that's pulling from the Earth into a magnetic field, and that's what that feedback does. It automatically converts the charge. When it's not doing feedback, it converts it back to charge.
To amps.
Charges the magnetic field, which is amps. Excuse me. Magnetic fields is amps. You got to think of it that way. Charge is mostly volts and milliamps. That's the way it works. So you have to convert automatically. That's why it has to self-fix. It automatically self-repairs the frequency for you. That's what the beauty of this thing. It's
So the
set up.
flyer's acting like an electromagnet, kind of.
In a way, yes, but it's always repulsing against the ground. Because you remember you're flipping the charge, but you're into a magnetic field, but you're also flipping the value. So if you see the ground as negative, it'll switch you to a positive. I think the ground is positive, so it would switch it to a negative and go up. So, because remember, the Earth is in reverse to the way you think about it. The highest field is in the center, not on the outside. So the center would be positive and the outside would be negative. Because the higher amount of energy, just like spinning a magnet, is closest to the magnet. So that side would be positive, and then the other side would be negative. So just a difference in understanding, I guess.
Well, positive and negative, they work together. Neither exists without the other. They flow in opposition, not opposition.
No, I understand that. But
They
when you're
kinda-
trying to repulse something off the Earth, you better know which one you're doing it to.
The positive and the negative need to meet each other through your load to have your load work.
Okay.
So, either the Earth isn't positive or the Earth is negative and the sky is positive. or either or, you know. But
Well, I think of it like this, okay? If you take the core, you take the Earth crust, then you take the outside field of the ozone layer, right? So you're closer to the core, so that part's going to get charged. So it's going to automatically pull down from the top and go down to the Earth and create the weight on it because it's creating a charge on the actual crust of the Earth, pulling you down towards the core. That's how I see it. It's that flow. It's just in reverse.
oh, right.
Yeah, it's just in reverse
I
and
see what you're
positive
saying.
and negative
Right,
when you
right.
set it up in a lab. It has to be, I mean, positive down here and negative up here when you set it up in a lab in order to figure it out.
And then you turn on the transducer and the flow
There's no
reverses.
transducer, by the way. It's just a piezo disc.
The barium, or
It's just a piezoelectric disc.
made out of barium,
I don't know if it's barium or not. It's I believe it's quartz.
quartz. Okay, so all you need is piezo vibration. That's not going to change, and that's what the material does.
Well, see, that's the thing. That material, it's a receiver and it's a transmitter.
Yeah, but it won't change its frequency. It's a material that will not change its frequency. That helps you stabilize your signal.
I don't want to say this. I don't want to give you the wrong impression. The frequency changes a lot.
And it does, but the material, the piezo material, is not going to change its frequency.
Okay. I don't even think that it takes into account a lot of that. It's just changing the frequency that's in it. Like, I don't know that it changes the
It's putting
piezo
its-
frequency
the
of a
material- The
piezoelectric.
material is putting its frequency into the circuit.
Yeah, however they built it, let's just put it this way, it changes frequency a lot. Whatever they built it with, it changes frequency a lot. Okay. And it'll do it in an instant.
And it probably changes its frequency around that base piezo material. Quartz or any piezo material is going to give you like a solid state oscillator of a static or a firm non-changing frequency.
Okay, yeah.
Like-
But hold
Kind
on.
of like a crystal oscillator, it's the same thing.
Yeah. It's got a
quartz.
bounce back signal. So when you tap anything that has, say, quartz in it, right? You tap quartz and it puts out the same amount of energy that you tap. Okay. So whatever you're tapping it with, it does the same. It'll put out that much energy. That's the way that works. It's not put energy into it because energy can't flow into it. It can't flow through it.
No, not energy.
it can tap
Frequency. The frequency, not the energy. The frequency. The quartz has a frequency. It doesn't change
Okay.
unless you break a little piece off that quartz. Then the frequency gets a little higher,
I disagree.
and that's not going to change now. That higher frequency,
Yeah,
because it's solid state. It's a solid state matter that's oscillating. Quartz is a self-oscillating piece of material.
It's like I said, it's the way you activate the energy. When you tap quartz, it releases energy. Okay, it's not an energy.
Yeah, but
in,
the frequency
energy out.
doesn't change. Yes, the energy, yes, but the frequency
The
that is not
frequency-
changing.
The
It's got nothing
frequency
to do
does
with the
change.
energy. The frequency has nothing
It
to
does
do.
change because when you tap it at a different rate, it'll change the rate that it comes out because it's not energy in, energy out. It's tap it and then energy comes out. So whatever rate you tap it at comes out as a frequency out the other end. So it'll change every time. If you're
Plus
talking about just resonating quartz, that's different.
Plus the
You-
frequency in between the taps is also involved. Because
wouldn't
the
matter.
quartz is resonating at its own frequency in between your
As
taps.
far as I know, I have never in my life ever seen somebody resonate quartz on its own. They cannot get it to light up on its own.
Okay.
No
If you
matter
buy
how
a
much
crystal
you put into
oscillator,
it.
it's a little chip called crystal oscillators. They have
I know what
set
it is.
frequencies
I
for
have
them.
them. I've used them.
Okay, that's
They
based on the
work by
size of the
tapping in and
quartz.
tapping out. They have two tuning forks on them. They run the tuning fork. The tuning fork taps it. Then it goes out to the tuning fork and runs it again. This isn't a hard system to figure out. It
You
does
can
not
send any
work by
frequency
energy
you
in,
want
energy
through the
out.
quartz, but the quartz is also going to have its own independent frequency as well.
Yeah, but nobody's ever hit it. That's what I'm telling you. You've never seen quartz light up by somebody turning on a frequency. Ever.
Oh, I didn't understand what you're saying there. I'm not going that route with lighting up quartz or nothing. I'm just saying the quartz has its own
Yeah,
frequency.
but we're not. That's what I'm saying. We're not taking advantage of its frequency. We're not hitting its
So
frequency.
you're not using that in any way. Okay, that's what I'm trying to figure out.
You're not. No one's ever does. They use the.
So why use piezo material to amplify your frequency?
Because it's like I said, you tap it and it turns it on. Okay, it turns on the energy on the inside. It's like hitting it with a hammer. It automatically light it up. It's tap in, energy out. It's not energy in, energy out. It'll go right around the quartz. It won't even touch the quartz. So if you want to resonate quartz, you got to resonate the oxygen inside of it.
Well, I mean, a crystal oscillator, they have all different frequencies on these crystal oscillators. You can buy them of different frequencies or little chips. So let's say you get one that has 109 kilohertz. You give it energy, it produces 109 kilohertz.
Okay, like I said, there is a tuning fork on each side of that piece of crystal. It resonates one to resonate the other, and it's consistent. That's what they do. You could pull it up and it'll show you the inside. You take the cap off, there's 2 tuning forks in there. That's what's going on.
Yeah, there's 4 prongs, you mean?
Yeah, those are the tuning forks next to it. They're stuck right on it.
Yeah, they tie into your circuit, and you give them voltage. The two in, 2 out. One in, one out.
They use it because it's consistent. Every time
Right.
you tap
It's the
it,
quartz
it taps
crystal.
out the right energy.
Because the frequency is consistent. Correct. It doesn't change.
Yeah, that's what I'm saying. But it's
But
not.
you can change your power all day long. The frequency doesn't change.
No. The frequency does change. You're not resonating the quartz. That's a lie. You're not doing that. Because you're not doing that, you're not having a consistent frequency.
Your ZVS is generating.
That's not what the
frequency
frequency's doing. That's not what it's doing. You're not getting the frequency of the quartz. No matter how hard you try, you're not getting the frequency.
I'm not saying getting the frequency of the quartz. I'm saying the quartz has.
But you're saying the quartz doesn't change its frequency.
No, it
and
doesn't.
I'm telling you, when you tap it at whatever rate you're tapping it at,
you have to change it. You have to change its frequency, but on its own resting, it has its frequency. It doesn't change.
Okay. When you can turn it on and light it up with the energy, I'd love to see it.
You have to change the frequency of the quartz by giving
by all
it
means,
your own frequency.
I'd love to see it.
But from what I understand about quartz crystals, they're set frequencies. You can shave a little bit off of it, change the frequency. So that tells you that the material doesn't change its frequency. You give it the power, it puts out the frequency it has to it at an amplified with amplitude to that frequency.
It could
so
change
the frequency doesn't change,
output,
but the amplitude does.
It could change the energy output, but the frequency always changes.
Right. So that's what I'm trying to figure. You have quartz or you have a piezo material in this device. You give it power. You're amplifying the frequency of that material with that power. Just like a quartz crystal, crystal oscillator works in an IC. So
I can't describe it any better than saying you've never hit the quartz frequency.
I'm not talking about hitting a quartz frequency. I'm saying
if you're saying it's steady no matter what, you're saying it's steady no matter what.
Depends on the size of the quartz. The frequency changes based on the size of the quartz.
The energy output does. Yes.
So the matter of quartz you have on your device determines the frequency of that of quartz, that quartz. So how much quartz do you have on your device tells you what the quartz frequency is. Then when you give it a frequency, that's different. But you could give it whatever frequency you want. The output of that quartz is going to be the quartz frequency at whatever amplitude you give it. Okay. It's not going to change. You can't change the frequency output of a quartz crystal from your input. That's how they make the cell phones work. So everybody has their own number because they have an individual frequency that's unchangeable.
It has to do with the tapping rate.
Well, of course, you could tap a piezo material and generate.
That's why I say
frequency. But as I said earlier, in between those taps, that frequency is still there.
The energy is still there.
Technically speaking, in between your taps, whatever the frequency of that quartz material is still there. It's not going to stop tapping on its own because you're not tapping fast enough to fill in the taps. So in between the taps, that quartz is still going to be vibrating. So I don't, You understand what I'm saying?
Yeah, but I don't agree with you.
It's not me you have to agree with. A crystal oscillator is a crystal oscillator, and it oscillates at a set frequency. It doesn't change because the dimensions and the geometry or whatever the mass of that quartz gives it that frequency. You take a little mass off that quartz and their frequency gets a little higher. You give a little mass to that quartz and their frequency gets a little lower. You can't change that. Not within the piezo material of the quartz. I don't know of other piezo materials. I don't know, but crystal oscillators are quartz. They're quartz crystal oscillators. And they're all over the place. There's billions of them in every device, you know, and they get all these little unique frequencies that way by sizing these quartz crystals to create all these cell phone channels.
It just changes the energy value. The amount of energy.
No, not the energy, the frequency value. The energy you can change, the amplitude you can change. The frequency will be the same. But the amplitude will be greater or less.
You cannot tap it at a different rate and get the same frequency. It doesn't work that way.
Tap what at? I don't know what you're talking about. Tap what at a different rate? What am I? I'm not talking.
You
about
have to tap quartz in order to get it to
I never mentioned
activate.
you tap the quartz at all.
I'm telling you, that's what you have to do. That's what quartz does. You have to tap it.
Well, they electrically tap the quartz.
They're tapping it with a tuning fork.
I don't know where this. I've never seen this before. I don't know what you're referring to. The tuning fork thing in the quartz. Never seen this.
Open it up. Take the little shell off the top. Open it up.
Oh, you mean inside it? Yeah, there's a tuning fork. That's the quartz.
Oh,
right?
now we can tap it with the tuning fork because now we know it's there. It has to tap that way. It's in there. There's one on each side of it, of the crystal.
You want to? Hold on. I tried to open the door 10 times. You don't listen. Yeah, inside those quartz oscillators, they have these little tuning fork-looking things.
On both sides.
Right, they're made out of quartz though, and they vibrate.
No, there's quartz in the center. I don't disagree with that at all.
But they give those things power, and they produce that frequency at whatever amplitude the power is at.
You would have a better chance of telling me that the tuning forks are set to the same frequency, and because of that, they resonate the same no matter what. I would buy that. But what you're saying,
inside the crystal oscillator, there's two tuning forks.
Yes,
and
they're set to the same frequency. I would believe that's why it's consistent. Yes. Okay.
I think they are. They're both the same.
That I can buy, but the rest of it, no.
What else? What rest of it? What? A quartz crystal has an input and an output.
Right, but if I was okay,
I mean,
I just tapped it on
oscillator, crystal
okay.
oscillator.
Let's put it this way: if I took some salt water and I put a piece of quartz in there, and I tapped it on one side, I'd get an energy output into the water because the water can handle the field of the energy. Right? You put the wires into the water, it'd give you a volts and amps out of it. Okay. Every time because it's creating electricity in it, right?
Because you're tapping the quartz.
Now, I can change the frequency by changing the amount of taps I give to it. I can go faster, I can go slower. It'll change the frequency based on the number of taps I put onto it. What I'm saying is crystal oscillators have two tuning forks. So they regulate the frequency. Okay? Tuning forks turn themselves on. Okay? One turns on, the other one turns on in a chamber.
They're matched though, the two forks.
Yes. So I would buy that the tuning forks themselves turn each other on. Yes, I'm there with you. And the amount of energy that comes out is based on the tap rate that the tuning fork's set to, that'll turn on the energy inside the piezo that'll flow. That I can agree with.
Right, but don't forget, the crystal oscillator has a frequency number written on it. And that's the frequency it will
because of the tuning fork.
Because of the tuning fork. And that doesn't change. That number's written on the crystal oscillator for a reason.
But we're not taking a tuning fork to this because it's not in there. This is a piezoelectric disc.
Right. I'm just saying that.
So the frequency changes everywhere.
The piezo disc is a bigger disc. It's got a lower frequency.
Okay.
Because it's got more mass. If it was a smaller piece of quartz, it would be a higher frequency.
Okay. You're not understanding. it has a back to it that's metal. I'm going to hit that metal, and then I'm going to change the frequency in the piezoelectric disc. Okay? There's no getting around that.
The quartz disc.
Okay, yes. I'm going to hit the piece of quartz here. I'm going to hit the piece of metal in the back and go like this. Okay? Continuously. Now, as I change that, I'm going to change the frequency. As I change it smaller, I'm going to change the frequency again. That's how this is working. I do not have a tuning fork in there. I do not have a regulation.
Wait, when you energize is that the transducer you're talking about?
There's no transducer. It's a
Or the
piezoelectric disc.
The disc, right.
Yes. That's why it'll constantly change.
And you're tapping it with volts?
Yeah, I'm tapping it with the
Hey,
magnetics on it.
The magnetic field is tapping it.
Yeah, every time that I pulse it, it's hitting it.
Oh.
we have
So
Mike here from
not a
Faraday
volt or
Research.
nothing, not a volt.
Yeah, it's not a physical tap. It's a pulse rate.
Because, like the crystal oscillators, they tap it with volts, like you're tapping it with a magnetic field, you're saying.
Yes.
Okay,
It's
that's
just
what
a
I'm trying to
pulse.
clear up, those
Okay.
differences,
We're good.
Hold on a second. Just
So that's
a problem here.
You're tapping quartz with a magnetic field.
Yeah, that's why it changes the frequency all the
I
time.
mean, I've never heard that being done before like that.
But that's why it's a receiver and a transmitter. It
I mean,
constantly
traditionally
changes.
speaking, have you ever heard it done like in regular, normal day electronics, tapping a piezo material with a magnetic field?
You could hit it with a pulse.
Oh, they
Slam
use
it with
those,
a high enough
those,
pulse, it'll turn on.
those water mystifiers do that, don't they?
I don't
Can
know.
I add something to this?
Yeah, go right ahead.
So I'm like,
Okay, I've been working with piezo's for probably about 3 years. Okay, the resonant frequency of a crystal is listed on the transducer or crystal set for radio, whatever. It has a resonant frequency, okay, from what I have, is about 41 kilocycles at 40 watts. Now, if you change the wattage going into the system, now you're going to get a lower octave of that frequency. So it's not 41 kilocycles.
that's how that works, right?
You're changing the amplitude.
You're right. He's right. I remember this.
Right?
That's totally true.
So now if, like, say in Nathan's case, he's pulsing the power into it. So the crystal never achieves the resonant frequency for that specific crystal. So to make the octaves go up and down, all you have to do is basically alter the amount of voltage input. So it is possible to get different frequencies than the rated frequency of the crystal. If that makes
no
any
doubt.
sense.
I'm just saying, but that crystal quartz has its own static,
Resonant frequency.
unchangeable resonant frequency as far as the quartz goes, not your circuit.
Yes.
Your circuit
Provided-
can oscillate onto that, change, not change. You're not going to change the quartz. You're going to add to it.
It has to be at the specific voltage rating or wattage input. You'll achieve that resonant frequency that the crystal is rated for. If you start changing the actual voltage input, now you're changing the amplitude, you're changing the frequency, everything changes. It all has to do with the power input. Now, if you're pulsing it, it changes it completely. Now you're getting into an area, say it's rated at, say, 41 kilocycles. If you're pulsing it, you might be lucky to get maybe 1 megahertz out of it, right? So, 1 kilohertz. So it dramatically drops that frequency down.
Right.
It all
'Cause
has to do with
they use, current to generate, the frequency of the crystal oscillator, not DC pulses.
right, but that's a consistent flow of power that's provided.
Right.
if you're
I understand
using-
that. So he's
Right.
pulsing though.
Right, that changes everything. The second
Right.
you
So
start pulsing,
he's not gonna have his quartz pump out its own frequency because he's pulsing. Right. Exactly.
correct.
Now, hold on, guys. So he talked about the octave.
said,
Just
Mike.
understand this. In the gravity flyer, the center plate has to hit the correct octave in order for the piezoelectric disc to work. Okay, in order for it to do its job, you have to have it in the correct octave. If you do not, it'll fall over, it'll bump, it'll do other things, but it will not jump.
Right. Which makes sense.
Yep. It's one of the hardest things to find.
Well,
You have to know what
that's
you're
it,
doing.
it goes
pulsing,
back. It goes right back to exactly what Tesla said: energy, frequency, vibration. So, and even with the energy, frequency, and vibration. If you get those correct,
Well, frequency is the vibration.
it's all intertwined. That's Tesla's secret, right? And he specifically goes and says that over and over and over again. Especially even when he got into the radio stuff, he was fighting for a patent, and they're saying, well, it's a Hertzian frequency, and he goes, no, my system is non-electromagnetic. It is longitudinal. It is not Hertzian. But to judges in those days, they had no idea what the hell he was talking about, because Tesla was the guy who discovered, the longitudinal wave. Nobody knew what it was. Only Tesla knew. And he said specifically in court, it is not electromagnetic. That's why the distance that a longitudinal wave is infinite. Where a Hertzian wave, you need the ray frequency, you need a ton of power to get it to go a certain distance. And it goes for all the radio towers of today. Same way. They use kilowatts, gigawatts to get transmitters to transmit power in the Hertzian frequency.
Hertzian was the horizontal wave, or
no? It's a wave like this, where longitudinal wave is a straight line. It's a very, very fine
horizontal
straight line. Because if you look at his original radio patents, Tesla's radio transmitter and receiver did not have a power source. There was no power input. So basically, you could take, say, a tuning fork, put it on a balloon, put it up, 400 meters in the air. You take another tuning fork 3/4 of a mile away, tap the one tuning fork, and the other one a half mile away is going to resonate at the same frequency as the one you just tapped, with no energy input.
well, energy was on the side where you tapped it.
Well, that was the only input, the physical hit of a tuning fork. The resonant frequency is the power source.
It's the transmission line.
And that was the basis of his original transmitter receiver. It did not require a power source. All you have to do is hit a tuning fork or whatever oscillator, and he'll transmit that power with no power and no losses at huge distances.
You seen that powerless coil radio system? You can make a radio out of a coil.
Yeah, it's just a crystal radio, the original crystal radio.
Yeah, you need a crystal oscillator too,
right? And that's kind of it's based on that same principle as the crystal.
Needs no
crystal
power.
Radio. I read a whole bunch of stuff on the old vintage crystal radios, and it blew my mind. There's no input power at all.
Well, the power for the radio signal is already generated at the transmitting side. So
no,
to receive it, you don't need power.
It's in the air. It's in the air. It's the antennas. It's using the atmospheric energy to actually make the system work.
That's interesting you say that, Mike, because there was some kind of radio rectifier circuit that Daniel Nunes made, and he just attached it to a giant antenna on his roof.
Yep.
And with the coil attached, it kind of amplified whatever was being picked up by the antenna, and it produced a tiny amount of free energy out of nothing, no input power.
Yeah, it's radiant energy. That's what it's powered on. It doesn't need a power source. The power source is the atmosphere.
You don't have to use a piezo material to do this, though. You could.
I'm
Even
sure there are many different ways
Copper
to
is
do
a
it.
piezo material. I don't think you can use. There's nothing that in electronics that doesn't have piezo properties to it.
Well, basically, when the first crystals, that's why Tesla was doing a huge amount of work with crystals in his mid to late 70s before he passed away with crystals because he knew they were a source of power. And obviously, down the road, they came in with the piezoelectric effect. And hey, Gerald, how's it going? Yeah, that's why he worked with it because he knew it was a free energy power source and it was able to go into resonant frequency with atmospheric electricity that's out there, free energy. It's all around us. So
Well, I mean,
One-
a simple coil is also
it'll amplify. It'll amplify as long as you got a huge antenna. You can collect that power. So yeah,
It seems
The
like
one
the
audio clip-
copper also, or copper or aluminum, all these metals are also, they have, they're not the best piezo materials, but they have.
no, they're great inductors. Yeah, copper's one of the best inductors other
But
than
they also
silver.
have
Silver
piezo properties to them, very subtle ones.
Hey guys, you want to answer this question? I wants to know what atmospheric energy is.
It's basically the static potential. We're living in a capacitor.
The
So the
barometric
bottom
pressure.
plate.
You talk about vacuum energy, right?
Well, no, it's we live in a capacitor. So your one capacitor wall is the atmosphere, and the other plate in the capacitor is the ground. So anything in between, that's the dielectric. So
That
when
creates
you got
the
the right,
barometric pressure.
so when you get the right atmospheric conditions, you get lightning, right? So it's a transfer of electrostatic charge from basically from an anode to a cathode. So the ground is the cathode, the anode is the atmosphere. So when the conditions are just right, you get electricity or lightning.
So,
So
Mike,
that
he wants to know, would you call it a dielectric field then?
yeah, well, the space that we live, where we live in right
Definitely
now,
polarizable, yes.
that is the dielectric space, right? So, when lightning decides to strike, it's going to look for the highest point possible to ground, right? That's why it hits the top of towers and buildings and whatever. So, it all has to do with the ionization of the air in that space. And the same thing happens inside a capacitor bank. When you got the right materials, you could get very large capacitance of a discharge inside that capacitor. It all depends on the materials used and how it's held.
Right.
But the actual electricity is not in the capacitor, it's electrostatic charge.
Yeah, they just store the potential on each plate. They store the positive potential on the one side and the negative
It's
potential on the other
electrostatic
plate,
charge.
and that's all that is. You're just storing, negative and positive potential on the two plates, and they're
It's
just sitting there
electrostatic
waiting.
charge.
That potential is just sitting there waiting for something to
It doesn't become
demand
electricity.
its potential.
It
like a
doesn't
load.
become it doesn't become electricity until it exits the capacitor.
Right. It sits on the plates as just static
Right.
buildup, voltage potential.
Right. It's a potential. So it's not actually power yet until it leaves.
You need the load to take the load.
That's why.
Take
That's like when you take a capacitor and you put the two leads together, you get that spark. That's why the electrostatic. The electrostatic charge that's there builds up so high, and the second has a way out. That's why you have a huge amount of amperage coming out of a capacitor. I've actually burnt my fingers on the capacitor leads.
Mike, did you ever see this?
So check this out, Mike. Tell me what you think's going on here.
All right.
You haven't seen this before, Mike?
Nope.
The metal shaft on the cable is like receiving a magnetic field from somewhere.
So watch, I'll play the part again for you.
Bottom left corner.
Just with the bioenergy of your fingertips.
Yeah.
There's a vibrational effect causing those two coils to generate a magnetic field between his fingers.
Yeah.
I think.
Yeah, he's creating electrostatic. Actually, it seems like his
Nathan
body
says
is-
it's heat transfer. I don't agree.
it-
I'm sorry, Nate. I just don't.
that's a,
That's okay.
yeah.
I think it's vibration because
It's not that you need the heat in order to flip the charge on the pipe into a magnetic field to flow it to the other
Right.
amount of wire. So
Yeah.
it has to have a heat transference.
I
to get
agree
the
that
amp.
he has does do that, but I don't think it's doing it in this case.
Well, friction. If it also don't forget the atmosphere that he's in. Is the air very dry or is it
It's
moist?
dry.
So so if it's a very dry atmosphere, I can see the effects actually getting enhanced.
But wait, because look, if you ever like a string instrument, like a violin, you ever, his fingers are rubbing the string like a bow for
Creating
a violin.
friction. Yeah, creating friction.
And remember,
That's what I'm
violin
trying to say.
strings, they require oil on the hairs because, it's horsehair. So, and
the
our
wire's
skin has natural
already,
oil, so maybe that has to play
insulated.
in it somehow.
Yep, it could.
The oil in the
I
skin.
see.
Right, right. That's a good point. Yeah.
I see friction happening there. If friction's happening, there's a good chance of electrostatics being generated there.
Yeah, because when you
Especially-
take when you take a rag and you put it over a piece of PVC pipe, you're generating a charge on the pipe, right? But it's only a charge. It's not flipped to a magnetic volt. It has no amps in it yet. So the heat
what I'm
transfers to the amps, which then allows the power to flow to the coil, to the other
Sure.
coil.
Yeah,
So
and
you're
now
saying the
creating
heat
a
allows the
field.
vibration to
Yeah.
communicate to the coil efficiently.
Because one thing I didn't tell you guys, and I told everybody else earlier, it doesn't happen when you're standing there. You have to walk away, come back to it, and then start winding it. So as soon as I come back, I'm bringing the heat back to the system. Now I'm allowing it to transfer.
I really think it's the winding of the
Right.
turning effect and the vibration of your finger pressing there and creating that vibration between your fingers and the wire. You're vibrating that wire with your fingers just by pressing, like piezo
I still
pressure.
think it's an electrostatic charge he's putting into the
How so?
coil.
It's insulated magnet wire. What conductivity is going on here? He's not physically touching the wire.
Let's go. You could go back to the heavy side component,
He's vibrating the
Right.
wire.
right? If there is a little bit of electrical charge in the wire, you're going to get basically a cloud of a dielectric field forming around that wire or magnetism, but also the heavy side component. And I think a lot of people overlook the heavy side of components in a lot of devices. So
That's on the outside of the wire, right?
on the outside of the wire, yep.
It looks a lot like it has something to do with the effect of rubbing against a string, like that, like an instrumentation.
It's still got to transfer charge, no matter if it's my arm hairs.
The vibration is transferring the charge to the whole wire, the whole spool. That
Right.
whole spool is vibrating at that
No.
frequency that your fingers are creating.
I don't disagree with that. I'm just saying it has to be able to change into a usable voltage to maneuver it to the other spool.
And you think the heat has something to do with that? Huh?
Yeah. Because the heat puts the amp in there, and the amp,
Yeah.
no matter how small, lets it move.
Yep.
I never knew that.
Creating a you're
Well, when
creating
molecules
a
are
displacement.
heated up, they have higher energy states.
Yeah. So it's the same
You're
thing.
cre- I think you're creating almost like a displacement current.
It builds up in there. As like I said, it builds up on the pipe. It keeps building. It's not transferred till it has a trigger.
Yep.
On the spool
Interesting.
itself,
On the PVC pipe. The
spool,
charge is
yeah.
in the PVC pipe. It's not in the wire yet. I need to transfer it to the wire. So I need to put an amp in it in order to get it to transfer to the
Oh,
wire.
so when your arm was heating it up, resting on it.
Could be my arm, could be my hand, it could be just a movement. Whatever it is, it's creating a charge in the pipe.
But
the
when
pipe-
your arm wasn't resting on it, it didn't work. Like, didn't do that. You're saying.
No, like I said, you saw it when it's working, right? What you didn't see was it would stop working after a while and then go dead. You'd have to tape it, come back, go away from it for a little while and come back.
Strange.
Yeah, that is
Interesting
odd.
effect. But yeah, like anybody who's interested in electrostatic stuff, I would start with a crystal radio set.
Definitely got to figure that one out. Exactly what's going on there, Nathan, because I mean,
Well, I don't think it's
verify
anything.
it.
I don't think it's anything different than if you put the wire up high in the air and it'll pick up the charge up there. I
Yeah.
think it's probably the same thing going on.
Pick up the
It's just in
charge
a
from
different form.
your body heat. You're saying.
Yeah, but like I said, the wire in the air is heat from the earth. It's going to get hot when it's up there, no matter what.
Oh,
so it's going to
right.
have energy. It's going to flip it
Huh.
into a,
That's-
it's the same thing as my body heat. I'm
That's a
just
good way to
bringing it
put
in
it-
at
put it.
one time. So like instead of it being steady, it's now an avalanche of heat because I'm sweating in there. It's hot. You know what I
Oh,
mean?
it was hot in there. I didn't know that. Okay.
Oh yeah, it's hot. No matter what you do, you're messing with wire and you're coiling it onto a tube. It's going to suck.
Right. No, I didn't know it was hot in there. I mean, if it's like a close to 90, 100 degrees, yeah, that coil gets hot. Yeah, you'd have residual heat energy in the coil already. Right.
Yeah, I just said, like I said, just got to have that trigger.
Vibration was the trigger to release the heat in the coil. Oh, that's what you mean when you walked away, came back or whatever. You let the coil build up some more heat before you discharged it again.
I took away the heat when I walked
but-
away. I took away
No,
the heat.
I think you
was
took
no
away
longer.
the heat when you discharged it. When you triggered it with the vibration, you took away the heat.
Yeah.
Now the other thing too is,
It was
I just thought.
okay. It was not. It was. That's a vibration.
No,
Now the other thing too is you might want to try this as an experiment, Nathan. Is do the same experiment, either standing on a chair or on a stool, that you're not grounded.
Okay.
So, or like rubber shoes or something to isolate you from the ground. Do the experiment with shoes on and without shoes on, and see if it.
No, I think he
changes.
had it right. The coil heated up, and he vibrated it and released the heat in form of
Yeah,
magnetism.
but don't forget, he is a ground source as well.
I don't think
Right.
it matters because the coil had heat stuck in it, and all you need to do is vibrate the coil to get the heat out of it.
Well, it would be one way to find out, like you said, sit on a chair, you know what I mean? Take off your
Yeah,
shoes.
if you're willing
I mean,
to be the guy,
Be the guinea pig?
yeah, go for it. But I think we nailed it down with the heat there because you didn't mention that it was hot in the room before.
Yeah, it's hot.
Because all you need to do is heat up the thing, and you have thermal electricity. So
They have transference. So it goes from one to the next, one state to another. That's why I mess with voltage. It's high because it doesn't lie to you as much as the low voltage does. It automatically tells you when it's changing. It'll show it in the voltage. It'll get thinner. You know what I mean? The higher the frequency you go, the lower the amp rating you go, it get thinner. All of it changes in high voltage very quickly. So
right, well, because you don't need all those amps anymore, because you're getting every amp through there with the higher voltage. You're getting more efficiency.
yeah. Oh, I was going to say the lightning rods. Basically, it's like putting a screwdriver in between your high voltage field. It'll pick it up right in the center. Okay. So if you think about it, it's those as capacitor plates. Then you put the screwdriver in the center, it'll pick up lightning to it and transfer it down, okay, to the bottom and try to connect through it. So when you have it to the ground already and it goes in there, it hits that first because it's the easiest point to get to where it wants to go, which is the field below it. So high voltage works the same way as the earth does.
Talking about the gravifier?
No, just in general. Like if I wanted to do a high voltage experiment, say I just wanted to light something up with plasma, I have to reduce all of the amps that I can, and I want to bring the frequency way up. Okay. Then I can get a beautiful plasma spray out of it every time. And like I said, you put a screwdriver in there, it'll start sparking out in that zone and it'll stop spraying. It'll just spark.
And that's why you're able to touch a spark that's maybe 100,000 volts. It won't kill you, but if you leave your finger there long enough, you might get an RF burn, but that's about it. It's not lethal. The second you introduce the amps in a lower voltage, that's where it becomes lethal.
Yes.
So,
or at the same high voltage.
well, high voltage, high frequency will keep you alive. Lower voltage and lower frequency is lethal. Like,
Okay,
it's like lightning hitting a cloud. It's like lightning hitting a cloud.
If you were able to get the
it's like a
amps up,
capacitor.
yeah, like the energy coming out of the wall, 120 volts, 60 hertz, that's lethal. And I'm pretty sure most of us know how it feels like. I've been electrocuted a couple times, not intentionally, but I have, and it doesn't feel good. Then I've touched Tesla coils that pump out 100,000 volts at a very high frequency, and I could keep my finger there for a couple of seconds and not be affected by it. So it all has to do high voltage, high frequency, safe, low voltage, low frequency, lethal. Simple rule.
well, high frequency, high voltage is usually low amps. Low frequency, low voltage is usually got amps, like more amps.
Well, it's low amps
Not
until
all
it
the
hits.
time.
It's low amps until it hits, say, a transformer. Then it becomes lethal again,
Yes.
right? Because you're
You're
amplifying
adding
the
amps back into it. You're transferring it.
right. Well, you're also
Trading volts
increasing
for
the
amps.
magnetic field. Yeah, you've created now a larger.
Well, they don't have
electromagnetic
switches that can
field
handle
core.
that kind of frequency and amperage, so you have to.
Well, that's why, back in the early days, Tesla didn't have all this equipment. That's why he invented the rotary spark gap. That was the only way he was able to get up to that frequency range because the technology wasn't invented yet.
There's no way to boost your frequency with a transformer, huh?
Well, you could pulse it.
No, I mean
As soon as you get
not pulsing it, just giving it the same 60 hertz AC signal and winding it another way to get a higher frequency. There's no way.
Well, it has to do with how it's wound.
You got to add a
so
capacitor to it to the secondary and to do that.
So yeah, so say for example, you got 10 windings on your primary and you got 20 windings on your secondary. So what's going to happen is in that voltage jump, which is going to be double, you also decrease your current by double as well, right? So as you bump voltage up, you lose frequency and you lose your current, but your voltage goes through the roof. If you're going a step down, so say from a high voltage, high frequency down to a lower voltage, your current now increases. So actually, toy makers referencing Steinmetz, and yes, if you want to know all about this stuff, yeah, it's definitely Steinmetz.
I think he's told me 100 times to read that book.
Yeah. Very good.
Steinmetz is probably the most prominent name of all the names that keep coming up from Heaviside.
Well, he was honestly, I think he was personally the last real electrical engineer. There hasn't been anybody since 1929 after he died. That was it. It was done. The electrical engineering at that level of knowledge was gone. There was nobody after him.
Someone mentioned 200 kilohertz being safe because of skin effect. I say,
yeah, you get the skin effect.
High frequency could jump over the surfaces of things, but again, if you are able to push the amps along with that high frequency, it can also incinerate.
You'll start to get RF burns.
But the thing I'm trying to put out there is that we don't have switches that can handle high amps, high frequencies, so you're not going to be able to make it.
Yeah, to a point.
You're going to make low amps, high frequency, because that's what we have the materials to do.
Yeah, well, they got some pretty good MOSFETs out there now that can handle.
They're getting there. They're getting there. You're right.
They're a little pricey, but
What are they using those for? Lasers or?
I think a lot of it's military.
Because they got these MOSFETs that are high frequency and they're getting up in the amp ranges now. They're getting
in the gigahertz range. Yeah, it's all laser technology and transmission.
They're developing this for the laser need for lasers, huh? What else would they develop it for?
Yeah,
there's got to be a reason for improving on switches and amp ratings of these switches. That reason I think would be like lasers. But what are they using? Lasers? Lasers are being used everywhere at your grocery store, I guess. Maybe, yeah.
I would say lasers is probably the most likely thing that they're using. Probably communications too.
What
high frequency?
High amp, high frequency.
High amp, high frequency.
Yeah, probably even microwave too. I wouldn't rule out microwave.
Right, microwave is high amp, high frequency. Yeah.
Because if you get hit with microwaves, they will.
But that's not using a switch.
Well, if you're using a high frequency MOSFET,
the magnetron does that.
Right. Yeah, the magnetron.
It's a material that generates that high frequency.
I think I have a magnetron somewhere here. Hold on.
It's the resonance chamber inside of a magnetron that does it.
I'm not too familiar on that, but
is it a material? Zap me in the eye, man. Things suck. I can't see things up close anymore.
What, microwave transformer?
Yeah, a magnetron. I was looking too close at it one day and turned it on, and bam, there went my vision.
With the field from it?
Huh?
The field from it?
Yeah, it shoots out. Like that. Doesn't shoot straight forward. It shoots out.
Magnetic field.
You have to use geometry to bounce it back in.
I'm trying to think where I have my.
So what is that? Magnetron is like it's a solid state device.
Here it is.
Yeah.
Hold on a second.
It's about energy flow. So you take a shaft, you take a spring that wraps around it, right? And it's a filament. So the filament heats up. Yeah. And then it's inside of a resonance chamber. So it has a cavity with equal chambers all the way around.
See that hole there? That's where the electron gets shot out of.
Yeah.
And there's the cooling fans.
So they feed 120 volts into a spiral cavity?
Yeah, and it makes a spiral field that goes around.
And it boosts up the voltage and the frequency, like that. Crazy.
Yeah, it's got two pretty powerful magnets.
You're looking at a guy that can't conceptualize any other way to generate a frequency than a switch.
Oh, well, he's showing it to you right there.
Yeah. Is there any other ways that they do frequencies without switches than the magnetron? Or is that it?
You could create frequencies about anything.
A particle accelerator is the same thing as a magnetron, right?
I would say a mechanical variable, what do you call not a rheostat, a variable capacitor, the old ones. That would do.
Frequency amplification, multiplication, a variable capacitor.
Yeah, variable capacitor, mechanical one, the old ones.
How would you get that to do the frequency multiplication?
Well, it would control the voltage going in, right? So if you control the voltage going in, now you're going to change the amplitude and the waveform to a lower or higher frequency, depending on how you turn it, right?
You change the capacitance on it and you move it.
Yeah, exactly. There was a guy named Chris Carson. He made a really cool electrostatic generator.
Oh, so you mean like a tank circuit? Yeah, I mean that's also still kind of switching, though. It's not switching. Kinda, yeah. Pulsing, right? Well, I already know that way. I mean, that's another way to create. That's not a switch, though. That's a pulse.
Yeah, if anybody wants to get like a reference on this, Eric Dollard and Chris Carson, type that in YouTube. They did a lecture back in 1996, I believe. It's really good. It talks about radio frequency, Hertzian, longitudinal. They show the ball bearing motor. They show all these demonstrations. I highly recommend it. Just in the search for in YouTube, just type in Chris Carson, Eric Dollard, 1996 conference.
So when's the last time they came up with a new way to multiply frequency without?
I think I watched that.
Yeah, it's very good. He really, Eric really explains the different types of frequencies and waveforms and longitudinal waves, how they differ, from the Hertzian waveform, right?
Yeah. I was doing the longitudinal wave. I came across it. It was like, God, I think it was like 6 episodes of it.
Yeah, it was cut up into several parts. I think you could get the one that has, basically the whole conference.
Yeah.
I think it's like 45 minutes or something like that long. But it was well done. It was very easy to follow and understand. It was funny. He was talking about the longitudinal wave, which it was kind of funny because there was a guy in the crowd saying, he was talking about the electrostatic potential, that it's the speed of light pi over 2. And he goes, well, the guy in the crowd goes, well, that means you're exceeding C. He goes, where's the limit? And Eric looks at him and go, what limit? There is no limit. So I thought that was kind of funny.
Yeah.
No limit to what? To C?
To the speed. There's no limit. When you're in a longitudinal wave, there is no limit to speed. It's pi over 2 to the speed of light.
Again, the longitudinal waves are going out horizontal, right?
Yeah, they're straight. There's no wave in it. It's an impulse wave.
Right. And the Hertzian is like also horizontal, but like a wave.
Yeah. That's exactly it.
Hey, didn't what's his name use that to blow up all that metal? The guy in Canada, what's his name?
Oh, Hutchison?
Yeah.
Yeah. He was using radio frequencies. He was using Tesla coils and Van de Graaff generators to get those effects. So I guess it was how he was putting all that into sync, into resonant frequency with each other, that he was able to achieve, levitation, right?
Yeah. But he also crossed the frequencies, didn't he, between the two waves, getting it to heat up in the core like a ball of energy.
That's how he was being able to, blow up those pieces of steel rod and aluminum and infusing stuff. Yeah.
Yeah. We were looking at that last time we were on APEC. I think it was Benny's show. We were looking at it with crypto.
Yeah.
And the thing was like,
I've spoken with John. The first time I talked to John Hutchison was probably about 2005. So I've known him for quite some time.
Huh. How's he doing? Is he okay? I heard last time he was in.
He's aging. He's getting up there now.
Gotcha. We're all going to get there soon.
Yeah, I think he's in his 70s now. Yeah. So, the test of time again, like Paul Babcock passed away last month, and, Chris Carson's been dead almost over 20 years. And all these old guys, they're starting to disappear now. There's only Eric Dollard and maybe Jim Murray left. And there's only a few of those old guys left. Everybody else is, dying off. So it's, for us, the younger generation, to kind of step up to the plate and,
Yeah. Younger, I wish. So I probably feel as old as them.
Anyways, guys, I do have to take off. I just wanted to jump on for about an hour or so.
Yeah, not a problem, man. Thank you for coming on.
Yeah, we'll do another show on my channel Friday night at 9:00 Eastern. So if you're available, jump on. I'll put the link in the live chat, Nathan, if you want to jump on, or Ben, if you jump on, I'll put the link up on the live chat there during the show, and then you just use that link there that's in the live chat.
All right, I'll do it then. 6:00 California time
Friday, Nathan.
on Friday.
Yeah, 9:00 Eastern. 6 Pacific, is it? Yeah.
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 I'll be there.
All right. Okay, guys. Have a great night.
Yeah,
All
Mike.
right, Mike. I'll see you later.
Thanks.
Ben got dropped out, huh?
Yeah, I think Benny dropped out too. I don't know what happened to him. He kind of disappeared. I didn't even hear nothing. Just maybe his internet went out. Maybe it finally gave way.
He's got a Ryzen computer. He's probably trying to run a bunch of stuff at once on there.
Hey, there he is. Hold on.
Oh, I'm still here. We're just cooking.
Oh, you just
I turned
disappeared
off-
for a while, huh?
Yeah, I turned off the camera because we're cooking.
Oh, you guys are making food?
Yeah.
Oh.
But yeah, he is right. I got a Ryzen and I try to run a bunch of stuff on Streamlabs. And it's honestly, it's not the computer, it's the internet that's my bottleneck. The computer runs everything fine. I'm not overloading the computer. It's the internet I'm overloading.
Oh,
We have DSL or cable or what?
Right now I think we got cable. Yeah.
Cable, you shouldn't have any problems. Maybe there's a lot of people sharing the line with you.
That's what it is.
Peak hours and stuff.
We switched to what is it, Xfinity?
Oh, you
And-
know what? I used to have them. They were kind of
And
problematic.
yeah, sometimes it's great. It works perfect. And then other times, I'd be like a bunch of people are using the line, like you said.
What companies do you have up there for cable?
AT&T, Xfinity. Those are the two that I know.
I use BreezeLine now. They're really good. No dropping or nothing. But
I used to have fiber optics in Florida. That was nice.
the way to go right there, fiber optics.
I had that for a good minute. Oh, it was so sweet.
Was it free when you had it?
No, but it was pretty cheap because they were like it was new in the area. So
Was that
they were running
Tallahassee?
deals. No.
Tampa?
No, West Palm.
West Palm had fiber? What year
Yeah.
was this?
Yeah, we had fiber in Loxahatchee.
What? When
Yeah.
when was this? Like recently or a long time ago?
No, recently.
Recent. Oh, recent,
Yeah.
There's still no fiber where I'm at.
Yeah, that's an area that's it's agriculture area and they're developing it. It's considered
Unbelievable.
like
Fiber
a
is seamless.
real
There's
estate
like
gold.
fiber optic internet is the bomb. It's seamless.
Mm.
There's no
Yeah, no, it was great. I could download stuff and stream stuff at the same time. I could do whatever the heck I wanted to do.
Your computer will never freeze because your internet's faster than your computer.
Right. And I did have this Ryzen set up when I was using it, so it was pretty sweet. I'm not gonna lie, I felt spoiled.
I don't know,
Yeah.
man. My computer's fast.
What are you working with?
I got a Ryzen 7 3800X with a 3080.
Is that 8
and
cores?
64 gigs of RAM, man. This thing just.
Oh, you
burned
got
me.
double the amount I have. Yeah, I need to up my RAM a little
Is that
bit.
an 8 core, Nathan?
Yeah, 8-core, 12 thread. I think it is.
Yeah. How much was it? Like 800?
I think I paid $250 for it, and that was a couple
250?
years ago.
Yeah.
Yeah. Oh, I don't
many
buy
years?
anything new on those things.
How many years ago?
A couple years ago.
2, 3?
Yeah, about 2.
See, I got my Ryzen 8 core. I got it for $700 used about 6 years ago.
Yeah.
Yeah, it's a good purchase. The 8 core, it's good enough. Now they got these 16 cores and 32s. Yeah,
I
What
have
a-
the 16 core.
just wait till they come out.
It cost
half
me like
price used
$600.
and upgrade then.
You got a Ryzen 9?
Yeah.
That's 16
It's
core.
nice. It was expensive though. It really was. I should have just gotten the 7. Honestly, I would have been fine with the 7.
Yeah.
I think I overkilled it a little bit.
How much was the 16 core?
I think I paid like 600 for it or 500. It was brand new.
Yeah, that's what I paid for my 8 core 6 years ago. So you're okay.
Yeah, I had a 8-core processor from AMD about that. Yeah, 10 years ago, and they had a lawsuit because apparently it wasn't 8 cores.
You had a what?
It was
Core?
I forget. It was one of the first line of series 8-core series from AMD, but it wasn't a true 8-core, and they had a lawsuit, and I won like $2 out of the lawsuit. And
Class
the
action.
CPU cost the CPU cost me like I don't know $200-300.
Did you have to fill in the form to get that $2?
Yep.
I love them lawyers, man.
Hey, those are some fries from McDonald's, Mike. Don't be laughing.
Oh man.
Yeah, I felt really ripped off. Honestly, I was very disappointed because I was an
bro.
AMD flag waver for a long
I gotta
time.
quit those fries.
Oh man. Yeah, you know what? They screwed me on one of my graphics cards. AMD did, and it was a 580 or something like that, and it was just they screwed up the software. So it was running. It was on my spare computer, and then all of a sudden they changed the software, and then it started heating up. And I think they did it because they wanted people to buy the new stuff, and it's like, dude,
Probably.
I haven't bought in one of their cards ever since.
Wow.
It's
Yeah, no,
not
I
worth
switched.
it.
I prefer AMD CPUs, but in terms of graphics, I don't go for AMD anymore. I used to. Now I'm all NVIDIA because it's like you said, like their software is imperfect. It glitches all the time. Every time I used to use it, the graphics drivers would crash, and it was just a big, they had some cool features, but at the end of the day, I need, reliability. You know what I mean? And NVIDIA is pretty reliable for that graphics demand.
NVIDIA stock blew up. I was thinking
It
about
is.
buying them.
Billy, Tesla hairpin circuit. I will put it on my list.
When NVIDIA was nothing, I was thinking about getting some of their stock.
Tesla's hairpin circuit, I believe it's page 52 in the Colorado notes. Is that right?
What is that hairpin circuit?
I might be thinking of a different one. It was like a circuit that switched from it wouldn't allow you to just dissolve the energy. It would use it. It'd bring it back to the system and allow you to use it. I could be wrong about the one I'm thinking of, but I think that's what it was. I'm sure the toy maker will tell me exactly what it was. So, part of the fun of doing some of this stuff is to actually go through it and learn it yourself. So kind of getting all the answers to the test kind of sucks because then you're kind of leaping forward those answers. I kind of like to understand it on my own, and then wait till I think I know enough, and then read the book, and then say, "Oh, well, maybe I missed this." So I think
no, it's true because reading the book gives you a bias. When you go into it blind, just with your raw knowledge, you know what I mean. Like you don't have any pre notions or you don't have any biases that you form.
Yeah. I have Eric von Daniken's book. I never read it. I wanted to read it. They talk about the ancient alien stuff, and I was just fascinated by it. So I bought it, and then I'm just waiting to read it. I think it's about time. I'm going to put that on my reading list. I don't read
Chariots of the Gods. I heard it was a good one. Yeah, I haven't read it yet either.
I wish I
That's
could
on
read.
the list.
I fall asleep. Can't stay awake, man.
Yeah, I have to get the audiobook and listen to it.
I don't
while
drink
I'm driving.
coffee.
Oh, well, you need to. No, maybe you don't. Not with all the stuff that you take for all the different, you know what I mean? Vitamins. You should be wide awake.
When I'm reading, my eyes just
go.
Energy. I just fall asleep.
I need a
pages.
good vitamin regimen. If you can send me a good vitamin regimen.
Niacin, zinc, zinc L-carnosine, nicotinic acid, the flush type niacin, and molybdenum, selenium, magnesium taurate. I have a video on my channel. You can see all the stuff I buy.
I also used to get this probiotic for your gums and teeth.
For your gums and teeth, molybdenum. Because molybdenum is what your enamels, you need molybdenum to make enamel.
What about I was getting something called like Salvarius. I
Look,
forget.
those probiotics, if they die at stomach temperature, they're
No,
working.
these are probiotics that are designed to be withstand the stomach acid. So
Not the stomach
they're
acid, the
intestinal
stomach
absorb.
temperature. Stomach temperature.
But they're absorbed through the intestines. That's actually their main feature.
Right.
That's why I was wondering.
And the temperature of the intestines is higher than the living temperature of the probiotics, so they don't survive. They never do. What gets the probiotics living in your gut is butyric acid. Butyrate.
So you have to mix it with the butyric acid.
Butyrate.
Butyrate.
You can get some exogenous ketones called butyric acid.
Mm-hmm.
And just that's a great way to boost your probiotics, natural probiotics, because
Yeah, it was interesting.
It's what they eat.
Well,
They eat the probiotics that are already in you that are able to live at those temperatures in your gut, unlike the ones you're consuming are not. They die at those temperatures, so they don't do anything. They're just ripping you off for your money.
right.
So you want to feed the ones you're born with butyric acid. It's like butter's high in butyric, but I don't advise eating butter. But you could take isolated butyric acid.
Yeah, I was watching a video on some ex-CIA dude who was talking about, you can kind of avoid like pretty much a lot of different ailments and illnesses and even cancer just by taking the right vitamins and probiotics and stuff like that.
It's plants, man. Plants are toxic,
Yeah.
and the more plants you consume, no matter how you consume them, or where they're sourced from, or what food or drink you ate, the more toxins are going to build up. Now, your liver has ability to break down these plant toxins, and most of these plant toxins are aldehydes, and the enzyme pathway of your liver is to break down aldehydes. It's called the ALDH, aldehyde dehydrogenase. So that pathway requires zinc, requires nicotinic acid, requires selenium, requires molybdenum, requires magnesium, potassium, and what else? Zinc, I said already. Molybdenum, niacin. What was the other one? Taurine is good. Taurine is the king of the amino acids. So, like, you want to get as much of the aldehyde forming substances out of your diet as possible, and the most of the aldehydes are sitting in what we like to call vitamin A, retinol. Okay, retinol.
Hey, Ben, is that your computer? I hear the keys.
Oh yeah, my bad.
So he's doing his research. So Ben,
I'm a good learner.
if you really want to absorb this data, go to Nutrition Detective's channel on YouTube, Dr. Garrett Smith, and subscribe to him and listen to him. He's really done the work in
Nutrition what?
Nutrition Detective. His name is Dr. Garrett Smith. His YouTube nick is Nutrition Detective. And he's on YouTube under that nick, and I think he's going to switch into Rumble because he gets censored a lot. So basically, his whole thing is about vitamin A toxicity. So retinol, it breaks down to an aldehyde. So these aldehydes they build up. You have to support your aldehyde dehydrogenase enzyme pathway of your liver to help keep these aldehydes down. Otherwise, the aldehydes will make your muscles and your joints stiff, and they'll create toxicities, and you'll just get toxic and more toxic, and it'll look like this, that, or the other. And by the way, this is not medical advice. Go see your doctor, blah, blah, blah. We just covered our ass on YouTube. And let's continue. What else do you want to ask about aldehydes?
Oh,
They're
yeah.
toxic, man. They're
All right,
toxic.
guys. Hey, we're doing a show about testicles, man. I'm learning about my stomach. Oh my god.
Yeah, we should return to
Zinc
do this another episode
stomach.
on this for sure.
Yeah, so zinc will get the retinol out, the excess, retinol, which turns to an aldehydes. So will taurine. It's a retinol
Just right
binding.
back to it. Like,
Sorry,
I just snapped the rubber
shut me
band.
up,
and
man.
Boom.
I'm hitting the mute.
Ah! I love it, man. I love it.
I
Come on, Mike.
apologize. Don't get me
Oh,
started.
Okay,
on
you
this.
get passionate. You get
Two
passionate. I
topics.
understand.
Oh, you'll get going on a roll. That-
The health topics and the politics.
Yeah, you get on a roll and you don't want to. I understand.
Oh my god.
Those are the two topics I can't stop.
Oh man, I keep politics out of my shows, man. It's just
Yeah,
it's a
same
disaster.
here.
I don't want anything to do with it.
Yeah, same here.
Oh, wow. All right, guys. Look, it's been 3 hours, so
Mhm.
I think we had about enough fun for the evening. What do you guys want to do next week?
Well, I don't have a lab, so I can't really present much, but we can go over a circuit or something like that. Maybe
Yeah,
a
we can
ZDF.
do. We can show everybody the Crumb simulator. I think that would be a good introduction for that, and mess with that a little bit. Like if you have anything to present, like circuit wise, we can mess around with the Crumb simulator and see if we can get something working in the simulator.
Have you learned how to use that yet? This is from then.
I don't.
Oh yes, I know how to use it. I just I'm not that good at building circuits, but I can build a simple circuit in the simulator.
Maybe you
Get
can
it
help
working.
me get used to the interface. I haven't gotten there yet.
Yeah, and I think there's a couple of tutorial videos on YouTube from the developers themselves that helped me.
Right, gotta check that out.
Yeah, they
He
don't
wants us
give
to
you
look
a
at
lot of guidance in
experiments,
the
but-
game. So it's like it's using a game engine to simulate circuits. So it's like a circuit simulator only in 3D. So you get your different components. You can drag them onto a virtual breadboard and kind of spin the camera around and get a 3D visualization of your circuit. Before you actually physically build it. And once you get the user interface down, you can actually run the circuit and see if it works and all that stuff.
And it's only $8.
Yeah, it's pretty
Yeah.
cheap. But yeah,
You
we
guys
can.
don't like blowing stuff up once in a while? You against that? I thought that was the whole fun of it. By double.
I
the
do
amount,
have
you can blow
an
up half of it.
Arduino kit too. I do have an two Arduino kits. So I got a whole bunch of electrical components to work
I'd
with.
like to talk next week more about how you modified your ZVS and the reasoning behind all that.
On like what, high voltage or something?
No, you changed the capacitors on it, right?
Oh yeah.
You,
I could-
you-
I don't want to move the circuit I'd show you. It's
no, not like that, but like what value was the capacitor before you changed it, and what is it now, and what's that doing for you on the?
basically went to a high frequency capacitor.
You
is
went
what
to
it
a
was.
lower Farad rating?
Yeah, lower Farads, yeah. So it
Yeah.
brought it down, higher frequency. It enabled it to do it without the heat. It's transferring it faster, so the heat doesn't
Right.
build up in the capacitor.
Yeah.
So instead of getting just a molten metal when you start turning it on, it'll actually oscillate.
Yeah, the capacitor will control your frequency, so getting a lower Farad rating capacitor will increase your frequency and lower your duty cycle.
Yeah, so
And there,
I don't know if it
saves
lowers
you
the
on-
duty cycle, but it brings the frequency. Yeah, the faster it goes. Yeah. So it doesn't have a chance to build up heat unless you build it wrong. Then
Right.
it does.
When it holds the switch down long, that's a long duty cycle. So you have a
Okay.
short duty cycle.
Yeah, very short. Yes.
When you hold it down long, that's when the heat forms. That's why.
That's the one thing you don't want. Trust me. I smoke so many wires. I keep putting them in thicker and thicker and start smoking and
That
smoking
was
them.
probably your duty cycle was too long. That's probably what that was.
Oh, it wasn't in resonance. If the coils aren't matched up right, then good luck, man. All you're doing is just creating a heat bomb. You're
The
just
frequency
melting.
was too low.
Yeah, it's one of the things about Tesla coils. The frequencies all have to be, in line with each other in order to work. So it'll be like when you're tuning this thing, it'll be like no, 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 yes, and then just a hair more, and it's no again. It's so picky. It's like, man, I hooked the clamp on there and left it alone. I didn't even bother to put the good clamp on. I just said, you know what? It's holding. We're doing it. So something I'll have to work out. But
You
yeah.
put the clamp on you were clamping the primary, you saying?
Yeah, the wire that goes into the primary, because you move it around to find out where your frequency is, right? And you take your oscilloscope behind it and you just put a wire up and it'll tell you the frequency on the oscilloscope. So as you move it left and right, the frequency will go up and down. What you're trying to do is match the number 1 coil, match the number 2 coil with the number 1. So you're moving the piece all the way around until it gets to that point. Once it's there, you lock it. Now it'll resonate properly. 1, 2, 1, 2, just like that. So if you don't, it'll just stay in the same spot and just create heat. And we all know what that does. It just melts metal. So it melts your wire first. Mine was smoking so bad. Every time I went to go redo it, I knew it was out of frequency. I did it anyway. And I kept smoking it and smoking it worse and smoking it worse. All the insulation came off that wire. It was smoked. Thing was black. You know what I mean? Created a whole charcoal effect all over the whole thing.
That's
And now that
hilarious.
you got it in resonance, you don't have any burning going on no more,
As a matter of fact, I use a thinner wire.
huh?
So it transfers it
Interesting.
so fast and so easy. I had a different, I changed the wire size to about a quarter of what it was.
Huh? Yeah, because a thicker wire would be able to carry more heat, huh?
Yeah, and I wanted to know when I was in and out of resonance. I wanted the heat
Yeah,
to be able to see it.
that's cool.
Have you drawn any diagrams yet for your system?
No, I haven't. I can. It's just all it
see.
is. It's
Oh,
two.
you got these videos that you made some diagrams, right?
Yeah. It's just 2 capacitors. We're taking out 4 and we're putting in 2. And I can show you that. That's fairly easy. You know what I mean?
So the Variac ZVS, and then the Tesla coil, and then the Graviflyer.
That's right. So it's crazy. You should try sitting in my garage and dealing with this thing when you're changing it all. Strange things start to happen in my garage a lot.
It's funny, like, why is it they used aluminum to try to get a magnetic effect out of aluminum? Why they didn't use iron or a real magnet? I don't know.
Well, think of it this way. It hates aluminum, so the field stays off of the aluminum. If you put in iron, it likes iron, so it goes into the iron. You're trying to keep the field off of the metal, so you want aluminum. You want that eddy current to force it out. That's why.
So you're like transmitting a field onto the...
You're trying to put it on there, and it's telling you no. It's like it rubbed it in lotion or oil or something, and it won't stay on there. You know what I mean?
So the transducer brings the field in, and then the discs say no.
But yeah, there's no transducer. Again, it's just a piezoelectric disc. That's on the top, but this is the high voltage going on to the plate. When the high voltage gets there, it won't stay on the plate because of the aluminum. The aluminum forces it off and creates a field around it. That's why you use aluminum.
But you bring it to the aluminum.
Yes.
Locally using the piezoelectric plate.
No, you're in a different part of the system.
How do you get the field from the coil to the aluminum?
High voltage, straight line. Use a wire. It goes on directly like a brush.
There's got to be something receiving the signal.
The brush is on. It has a brush. The brush goes on the disc. The disc turns. It touches the brush, just like that, and it transfers.
What on the Graviflyer? What part is receiving the signal from the Tesla coil?
The center plate.
And that's the center plate. Okay. And that's aluminum disc.
That's aluminum disc, yes.
And it's receiving the signal.
Yes.
But it doesn't want to receive the signal?
It doesn't like to stay on it, is what I'm saying. It's like where if you put in an iron will suck it up and it'll be in the iron.
Oh, okay. But it's still
the aluminum stays off.
So it still acts like an antenna, but it doesn't want to absorb any of the signal.
Yes. It stays off it. That's the whole point of using it.
But it will still act like an antenna.
Yeah, because you wouldn't be able to move the field if you didn't. It'd be locked in the iron and it wouldn't be able to come out. The reason
Yeah.
the aluminum is it wants to stay off of it. It hates it. The more energy you put to it, the more the aluminum bucks back.
So the aluminum in one token, it's receiving the signal. On the second token, it's only receiving the signal on the outside of the shell of the aluminum, but it doesn't want to absorb any of the signal per se.
Yeah.
So it forces the signal to wrap around it.
And that's
creating
why
that
you get
bubble.
feedback in your Tesla coil, because it doesn't want to stay on the plate. So it's movable. So when you change the frequency rapidly, boom.
Stay on the plate or stay on the entire flyer?
It doesn't want to stay on any part of it because it's all aluminum.
All aluminum, right.
Yeah, the only thing that's not aluminum is the rods.
Yeah,
So those are steel. But other than that, the whole thing's aluminum. You know what I mean? The whole frame of it. Even the little bars on the top and bottom are aluminum.
You think maybe that those steel rods are interfering somehow with the lift?
You know, I don't know. Some people have tried aluminum. Some people have gone to stainless steel. Alexi uses steel, so that's what I use. I haven't found any problem with it.
Oh, so you know he was using steel also, so then that's not the issue.
Oh, Charlie C has the whole thing, and he's got the original gravity flyer. So he's taken it apart, taken measurements, told you exactly what's in it. I did a whole video on it.
I missed that one.
Yeah.
Well, it sounds like this is worthy of another episode for sure.
Yes, it is.
Yeah.
Well, look, if I start playing with this thing and this circuit works out on my my other one for my gravity flyer, we're going to be talking about it because it's the last time it did some special things, and then this time it should do them again, but this time hold it. So I can't. Yeah,
definitely not ion wind. Not ion wind.
It's not it. It doesn't even.
It's a magnetic effect.
No, the thing is too heavy for ion wind. You see those little cheap ion wind demonstrations they have on YouTube? The things are so light. This thing is heaviest, in comparison. No, not a chance.
There's ion wind that mixes the fields around, but it's not. Yeah, like you said, it's not very heavy.
Yeah, I'm sure it plays a role, but it's not probably what's activating the anti-gravitic well or whatever.
I've seen videos of people. I've lost where these videos are on YouTube, but they make these coils, electromagnets that are specially made to pick up like gold and aluminum. So you can magnetize aluminum. Yes, you can. It's just a frequency, the right frequency, and the electromagnet. When you energize it with this different type of core material, not necessarily iron. I don't know what core material they were using, but they did pick up aluminum with an electromagnet. I've seen it on YouTube. I don't know where the channel is. It was years ago. They also picked up a piece of gold, And it's all about the electromagnet at what frequency it's operating at. So aluminum is magnetic at certain frequencies.
You got a video of that?
I wish I did. I probably did download it. I don't know if I downloaded it or not.
Yeah, see if you can find it for a future episode.
I look for this channel or this video occasionally, but you probably could find.
Sometimes these videos get taken down. I know that.
They sure do. Because if you could build an electromagnet that could pick up a piece of gold, that means you can build a sensor to detect gold a lot easier than your modern day, metal detector can. So
right, you would see gold detectors instead of just metal detectors out in the market.
Yeah, so it's basically the keywords is magnetic gold or electromagnet picks up gold. They're out there.
They're Veritasium.
People are building these special little electromagnets.
Marvel element.
Using specialized core materials. I think they don't use iron per se, and I guess that changes the frequency that the electromagnet is operating at.
And picks up gold?
Yeah, I've seen it. I'm telling you. I know you don't believe me, but It's all right. I'm telling you, I've seen this on YouTube. I don't know if it's still there or not. I've seen the guy build an electromagnet because I spent the last 12 years searching up stuff in this realm, electronics and stuff like that, and things like this. And I landed on a channel where the guy was picking up with an electromagnet, a special electromagnet that he made. And from what I can tell, the core didn't look like it was just iron, like it looked like he was using maybe stainless steel. It looked like stainless steel, or it could have been an aluminum core. I'm not sure. You see? So like just running a frequency through an electromagnet with an aluminum core is an experiment on its own. These type of things don't get done regularly, you don't,
No.
but they should be, like everybody's putting iron inside of a coil. Why not gold or a golden core or a golden alloy core or a silver alloy core, or mix metals to build your cores with. So that's what these guys were doing to lift the gold, basically, or the silver or the other non-magnetic materials that we know not to be magnetic. And there you see them in the video picking up an electromagnet, sticking right to it.
That'd be the coolest thing, because then you can just go over the sand and pick up all the gold.
Well, that's probably why they're trying to build these things, to find that,
That'd be awesome. You see all these people on that what was that big nugget show or whatever for the gold rush, and they get all this gold. I just put over a magnet. Let's get it.
Well, I mean, it's an expensive electromagnet to make because you have to use aluminum core or things like that. It's probably not the cheapest thing to make.
These people spend $1 million on a shifting machine. They can get anything they want if it works.
Right. I'm just saying you can build an electromagnet to attract what we know to be non-magnetic metals. I've seen it done.
I don't doubt it.
On video.
I just want to see how it was done. You know what I mean?
What I remember from looking at the electromagnet, the core did not look to me to be iron. It had a whitish stainless steel look to it. Could have been aluminum. Now it's possible to lift. He was lifting aluminum in that video, and he did. I think it was aluminum. The core of the electromagnet was aluminum, and I think he lifted the aluminum with it and a piece of gold with it. Once I get my lab going, you can guarantee yourself that I'm going to be trying to do stuff like that with core materials, and not for finding gold or nothing, just for scientific reasons.
Yeah, maybe find the gold in your backyard, cash it in, buy some
Research.
material. Yeah.
Or you could do what Crypto's doing and try to transmutate it, grow it. He's working on electrochemistry.
Oh man, if I could find gold, dude, it'd be over. Because everybody's backyard would get searched. We'd be like, oh, well, split the number with you.
If you got a piece of gold at your house and you got an electromagnet, take the core out of there and put a piece of aluminum in there, or stainless steel.
I think one of the people on the chat said
metals,
there's gold flakes in the ocean, so you could use that in the ocean, huh?
Oh, that'd be
gold
great.
flakes. Well, those are like, you're talking about the nanoparticles of gold, right?
I don't know. That's just what they said. I'm assuming.
Oh yeah, the seawater has monoatomic gold in it and monoatomic minerals all together, because the ocean's full of
cobalt,
lava, and
look at that.
And all that.
Oh yeah, everything that's coming up from the inside. Yep.
Check it out. Cobalt, you put it in there, superconductor when it's cold, and it acts like aluminum when it's not. So it'll give you a very, very small amount of currents in there, and then super cool it'll give you a huge amount. So if you wanted to create the magnet side of a motor, it'd be perfect. And you just got to supercool it. That's it. And it has a lower supercooling temperature than most metals. Cobalt.
Is the magnetic field stronger than the neos, or?
Oh, it's way stronger.
Really?
Yeah.
Huh.
So, like I said, it becomes a superconductor.
So in space, you would be using cobalt for your magnets.
Oh, absolutely. So easy to start. As soon as it started, boom, super cool it, and let's get going. So definitely do that.
That's a new one. They don't, not your obvious,
Like you said, nothing's obvious, man. They're using different stuff for cores, so it's all going to change. When we start doing that, man, it's going to change everything for everybody.
They keep us here down on the ground, us simple folk. They keep us simple.
Yeah, and then they get these people up there that talk on the TV like everybody's an idiot, and then they start building models of the universe and telling us that's what it actually is, and we're all, yeah, it looks cool. They got a diamond planet. I want to go there. It's like, dude, do you really know it's diamond? Like, seriously?
Yeah,
I saw a face on Mars and you won't admit it. You know what I mean? Like, what do you know?
I don't care if the planet's made of diamonds. There's then no reason to go there.
My
Yeah,
thing
diamonds
is,
here.
how do they really know how accurate their pictures of all of these distant planets? Just with the limited technology we have, they're making guesses.
I think
They
they
can't
make
even
stuff
give
up
you
just
a
to keep you
clear
thinking.
picture of Saturn. I mean,
Yeah.
or Jupiter, and it's in our solar system. How the hell are they getting way out there?
Yeah. But when we get the Graviflyer working, man, we'll get our own pictures.
See me riding on top of it.
You seen that hexagon on Saturn?
Hexagon on
pole?
Saturn? No.
Yeah, look it
No.
up. There's a cymatic hexagonal shape formed by the sounds of the planet. So they call it the musical planets or whatever.
Yeah,
the music of the spheres.
Yeah, there you go. It's true though. The planets have a sound.
Yeah.
They vibrate.
I don't think there's an iron core. I think it's a resonance chamber. And
Yeah.
That probably goes against what everybody thinks, but it
You mean
puts
Earth?
out all the heat. It puts out everything. Puts out frequency.
It makes sense.
It doesn't have to be iron, no. It could be a resonance thing. Yeah. Iron's a good way to keep us simple folk simple, though. It's iron core.
Yeah, you think it'll start melting through something by now, huh?
I mean, there's iron on the planet, no doubt. Most of the planet is iron. That's a fact,
Yeah, but you get lava and it burns and eats cars and everything. How is it staying perfectly in one sphere? I'd love to know.
You mean the iron?
Yeah, I mean, how do they keep it? I mean, it just doesn't.
All the metals get mixed up.
Yeah, it doesn't make any sense.
Well, when you do mix up all the metals, that's what creates all these eddy currents and your magnetic field. But it doesn't, having an iron core is it's more about the mixture. The mixture, I say. You can have just iron too, though. I mean,
yeah, it just doesn't make any sense from a logistic standpoint to build it. It makes no sense. Like, you would have to have a magnetic chamber in order to hold it in the spot that it's in, floating and spinning. That you could do, but that doesn't seem like a process that's done when you're building a planet.
Well, guys,
how do you?
I'm gonna call it a night.
It doesn't make sense.
I gotta get to bed so I can get up early in the morning for work.
Oh,
so
okay.
I appreciate everything. I appreciate Nathan for hosting this amazing show tonight, and Mike and both Mikes from coming on, and all the amazing chats. And I'll catch you guys next Monday, or actually Friday. Yeah, we got that thing Friday with Mike.
Friday.
All right,
guys, I'm out too then.
See you guys.
Right. See you guys
Have a
later.
good night,
Thank you guys
everybody.
for the show, everyone.
Stop by Friday, Nathan.
Friday. I'll be
Friday.
there.
Yeah.
All right. Talk to you guys.
Bye.
See you later, everyone. Thank you for watching.